Good morning and welcome to the Public Safety and Homeland Security Bureau's Interoperability Forum. We appreciate you being here, and before I forget to, I'd like to thank Jennifer, Susan McLean, Joanne, DeAndrea, all the people who have worked to put this together, and certainly I appreciate your effort in coming out and waiting in line to get in this morning. We're entitling the discussion this morning, a discussion on creating and implementing the technical framework for the National Interoperable Public Safety Broadband Network. This morning's event follows the Commission's recent adoption on January 25th of an order and further notice of proposed rulemaking to advance public safety broadband network interoperability. In this order, the Commission designated 3GPP Release 8, or Long-Term Evolution, LTE, as a common technology platform for public safety broadband networks operating in the 700 megahertz spectrum allocated for public safety broadband services. While this is a crucial first step towards interoperability, it is far from sufficient. The Commission therefore sought comment in the further notice on the development of a more refined technical framework to guide the deployment and evolution of these networks. The key components of this proposed framework are the topic of discussion today. We've assembled 4 panels, each composed of a diverse array of experts to examine and discuss the technical requirements for a truly interoperable nationwide public safety broadband network. And I look forward to a spirited and enlightening discussion. Since I joined the Bureau in 2009, I've appreciated the emphasis that our Chairman, Janikowski, and the other commissioners, quite frankly, have placed on public safety and to making sure that our first responders have access to the most up-to-date and innovative technology to help first responders do their jobs. This commitment is reflected really in the National Broadband Plan, which is nearing its one-year anniversary. It presents a comprehensive framework for the construction and operation of this nationwide interoperable public safety broadband wireless network. The vision set forth in the plan is designed to ensure that the network meets the fundamental requirements of the public safety community. And in particular, we envision this network that is truly nationwide in its geographic scope, that achieves nationwide interoperability, that satisfies public safety's unique needs for coverage and mission-critical reliability in emergency situations, that is both technically and commercially viable so that it will not be cost-prohibitive to public safety agencies with limited resources, that leapfrogs public safety to advanced 4G broadband technologies and keeps pace with evolving technologies as they develop, that it captures economies of scale in equipment and services costs, and that it catches the wave of commercial broadband deployments already occurring in order to save significant amounts of money. So one of the things that we certainly have found out is that interoperability is not a naturally occurring state. And at the FCC, we will continue to make interoperability the first priority on the development of these networks. And therefore I would say that interoperability has to be in line and first in line, that everything else has to be subordinated to it or make sure that it supports interoperability, whether that's governance, funding, structure, architecture, anything that's going to go into the network has to have interoperability as the first priority. The third report and order and fourth further notice adopted in January moves us closer to realizing this vision. This order moves us closer to interoperability by designating a common technology platform for 700 megahertz public safety broadband networks. Now this is an unorthodox move. The Commission typically does not select competing technologies and prefers to leave these decisions to the market. But the designation of LTE as the standard for public safety broadband networks is justified by the crucial need for interoperability, a fundamental goal of this proceeding and the topic of discussion here today. LTE has emerged as the technology of choice for 700 megahertz public safety broadband networks. Public safety has stated that to us particularly, and its adoption as the common technology for these networks is that first crucial step. Now in the further notice, the Commission seeks comment on a broad array of issues relevant to public safety broadband interoperability. It seeks comment on an architectural vision for the network, on whether high-level principles should be established to guide the network's development. Another major focus of the notice is how to implement a public safety roaming regime. The ability of the public safety personnel to roam on the public safety networks outside their jurisdiction is an essential component of interoperability in our thoughts. And accordingly, the the further notice seeks comment on a host of issues relevant to the development of viable roaming framework for these networks. The further notice addresses many technical components of interoperability, such as network identifiers and system interfaces. It also proposes public safety equipment and devices undergo testing to ensure that interoperability is truly achieved. Other issues addressed in the further notice, such as performance and coverage, are important to ensuring that public safety networks achieve the baseline operability necessary to support interoperable communications. So, as you can see, the further notice covers a lot of ground. There are a number of issues in play, many of them highly technical and complex. It is my hope that today's discussion will help the Commission and the Bureau focus our thinking as we proceed in the next phase of this proceeding. Now, we'll cover a lot today, so I'd like to go right ahead and introduce our first speaker. William Caro is the president of the Association of Public Safety Communications Officials International. Bill has been active in public safety communications for over 29 years. He started when he was 10 years old. The last 11, he served as the communications chief of the Delaware State Police. And those duties include administration overall of 3 911 PSAPs, the Computer Data Center, and a Communications Technical Support Unit. He is an award-winning leader, having received the Leadership and Technology Award from the International Association of Chiefs of Police in 2004 for his accomplishments in the field of communications interoperability with Delaware's neighbors. He was also named Civilian of the Year for the Delaware State Police in 2004. So would you please help me greet the president of APCO International, Bill Caro.
Good morning. I wish it was true that I started when I was 10 years old. But anyway, my name is Bill Caro, and I am the president of APCO International. And it's my distinct pleasure to welcome everybody here this morning, especially the panelists that you'll hear throughout the day. I truly consider this a monumental occasion as we truly sit on the cusp of what's going to be the nation's public safety broadband network. So what we do here today really sets the cornerstone for all that. A forum like this is crucial to ensure the key stakeholders at least have ample chance to have buy-in and to make key decisions and bring issues to the forefront, all designed to ensure nationwide interoperability. The word interoperability I really don't think existed prior to the horrific events of September 11th, 2001. We're all more than familiar with what happened on those tragic events, and we learned lessons from them. The lessons learned early all dealt with radio interoperability. And I'm here to say that interoperability on a radio system really doesn't mean everybody has to talk to everybody else. And hopefully we've learned from that, because if you try to do it that way, nobody gets a word in edgewise. My paying job, as was mentioned, is Chief of Communications for the Delaware State Police. And I'm fortunate that my state spent millions of dollars back in the 90s to develop a full public safety radio system that has all state, local, county partners as well as federal partners on board that have offices within our state. We no longer have to hand a radio across the hood of a car to accomplish interoperability. We come to the table with our own radios with mutual aid talk groups pre-programmed so that we can communicate together. Planned events such as the Obama Whistle Stop Tour, NASCAR events at Dover International Speedway, and Returns Day parades that include the Vice President of the United States, since he is from our state, are just a few of the events that have proved the benefit of that radio system being built right using key stakeholders. Unplanned events such as the C-5 crash at the Dover Air Force Base also showed how the system works exactly the way it was designed to work. That design took pre-planning among key leaders. Today, we experience interoperability not only with our first responders in Delaware, but secondary responders such as utilities and public works. Let's not forget for 1 minute that there's times that without their assistance and direct communications, we couldn't get our job done and accomplish our mission. Parallel that to what's going to begin in this room today. Multiple panel presentations will take place that include some of the best in the business. These discussions are designed to inspire thinking outside the box, all with one goal in mind: to achieve true interoperability on the National Public Safety Broadband Network. Will the issue be solved here today? I doubt it. There are so many unknowns, but the cornerstone will be set here today. If we do that and come away inspired, forward-thinking, and prepared to continue on the course, then we're stepping off on the right foot. APCO applauds the FCC, the Public Safety Homeland Security Bureau, and ERIC for hosting this forum. We have a chance to get it right this time for all first responders. On behalf of APCO's Executive Committee, we pledge to work hard so we can all cross the goal line together. So again, good morning and welcome.
You tell me APCO does not pay you? I didn't. So, Bill, thank you so much and for kicking us off today. I think you'll find that all of our panels, as Bill mentioned, are going to provide a great discussion. Since I'm speaking now, I'd like to thank this first group for being here, and I'd like to turn it over to Dr. Behzad Ghaffari of our Emergency Response Interoperability Center. Many of you know him, but if you don't know him, you have definitely seen his work as our interoperability items have come out, because he is one of our key leaders on that. So if I could at this point turn it over to Dr. Ghaffari. Thank you.
Thank you, Admiral. Good morning. I'm Behzad Ghaffari, System Engineering Chief of the Emergency Response Interoperability Center within Public Safety and Homeland Security Bureau at FCC. Welcome to today's event, which is a forum on developing a nationwide interoperable broadband network for public safety. The first panel is that we start is focused on nationwide interoperability for this network using LTE. We'd like to explore ways to advance the goal of nationwide interoperability through capabilities, technical and operational, offered by LTE, and also would like to make sure the open standard and commercial technology is being used. And we verify interoperability through certain ways, testing and otherwise. These are the sort of things that we'd like to explore in this panel. I'm very happy to introduce our panelists now, a set of distinguished members of technical community with diverse and impressive background. Our panelists are Dr. Kenneth Budka, Senior Director, Advanced Mission Critical Communications, Bell Labs Alcatel-Lucent; Mr. Brian Daly, Director, Core and Government Standards with AT&T Mobility Services; Dr. Dennis Martinez, Chief Technology Officer with Harris RF Communication Group; Mr. Emil Albrecht, Project Lead with PSCR Program and NIST. To our panelists, I would like to thank you for accepting our invitation and coming from long distances, as far as I know, from Washington State, Colorado, Massachusetts, and New Jersey. And now I ask each panelist to present their view, first to introduce themselves and present their view on the topic for like 6 minutes. Then we'll continue our discussion with question and answers. And at the end, I'll open the floor to audience and web viewers for additional questions. So we'll start with Ken.
Good morning. I've got a clicker, but I'm not quite sure what to do with it. Can you bring up a presentation? Thank you. Good morning. Thank you. My name is Ken Budka from Alcatel-Lucent's Bell Laboratories. It's a pleasure to be here. Also a pleasure to see the progress that we've been making in public safety broadband after it's been almost 9-10 years since September 11th. Still got a way to go. And I have the pleasure this morning of, at 9 o'clock in the morning, talking about testing, something that I know will get everybody's blood boiling. But testing in and of itself is one of the most important things to ensure interoperability, not only on day one, but also going forward. Because LTE itself is an interoperable technology, but the reason it's interoperable is not the words on a page of a specification. It's the fact that vendors throughout the community get together, test equipment, test devices, test network equipment. And as we look to take this same equipment and apply it to public safety, we'll be using different features and new ways of using LTE as dedicated for public safety. As we make this step, if we don't make this step carefully and do it in an open manner, and do it with testing, inter-vendor testing, scenarios that describe how LTE will be used for public safety, we will end up with the same mess we have today with our land mobile radio systems in the United States. So I just want to give you a view of what's happening with LTE and commercial technology that makes commercial LTE so interoperable. And if you look at the testing steps, this is a view of Alcatel-Lucent's and all other vendors' testing processes that work in the commercial space. It's sequential. You don't have a network without devices, and devices come from a wide ecosystem of device partners. Device vendors bring their equipment and start doing some initial testing with primarily some air interface emulators that test some basic functionality, basic capability to make sure that stuff works. Then the different elements that make a network work are brought in and tested. Then they're mixed and matched together like Legos and tested as part of the network. And then once we've got that level of interoperability tested with our own equipment and our device partners, then we go and actually do a full end-to-end network level test. And one of the most important things for building an interoperable public safety network or commercial network is actually rolling that network out into a field setting and testing the things that you cannot test in a laboratory environment. This is something called first office application, and something that is an absolute necessity for public safety as well. Throughout this whole process, we're also testing to make sure that the devices and the network is working as required in terms of the performance required, throughputs, delays, packet losses, etc. That runs through the whole process. As we look forward to using LTE for public safety, there are pieces of the LTE network and devices that are going to be unique to public safety. Devices are going to be in different bands, different form factors, may also have different interfaces to get access to network features. The network elements themselves are going to have some special features to use the quality of service and preemption and other capabilities that are standard in LTE, but have to be used in a way that is standard across all vendors and across all networks so that this stuff works as needed for public safety. So there's ways to leverage a lot of the existing testing that's going on, but at each step of the way, there's some little bits of testing that need to be done specifically for public safety. Devices, different band. Also, first office application. Right now for the BTOP networks that are being deployed, we're using the Public Safety Communications Research Lab in Boulder. Emil will talk about that later. Our LTE equipment is up and running in that laboratory environment for that type of inter-vendor testing. So inter-vendor testing. This is the absolute most important thing for making sure that devices from any operator, any vendor work, network elements work. This happens today among competitors. And it doesn't happen naturally. It happens as a result of contracts and requirements for the equipment. We don't necessarily will go out and say, hey, competitor, come and play with us. It's our customers that come to us and say, we're building a network, we need to test. So we sign an NDA, we work across our laboratories and test our networks, develop a test plan, and it is that testing that ensures interoperability across networks, across vendors. It's an absolute must, and in commercial wireless, you don't get your check if you don't go through that testing. Another critical piece for interoperability is not only the network, but the open APIs. APIs are the things that take a network and turn it into something powerful for public safety. Take the applications and allow the applications to be able to send videos in an open standard way with priority, with preemption, with all the features you would expect in a public safety network. That must be done through open programming application interfaces. These expose the public safety specific features, encryption key management, device state, all these other features that are used by applications to make LTE valuable for public safety. That should be and must be open and open standard. Similarly, on the device side, to encourage openness and encourage an environment where there's lots of competition and lots of innovation, those device APIs also must be open so that devices know in a common way how to request to send video, how to also manage all of the quality of service and preemption in networks. Those are my comments. So just a word of caution as we move forward with LTE, that is, it is not enough to adopt a standard. Testing, requirements, scenarios, everything is important to make sure that this network works as promised and as advertised. If you don't make this step correctly today, we'll have the same mess we have with land mobile radio. Thank you.
Brian, you're next.
Good morning. As mentioned earlier, my name is Brian Daly. I'm the Director for Core Network and Government and Regulatory Standards at AT&T. If we could bring the slides up, please. First, I'd like to talk a little bit about what the definition of roaming and interoperability is from a standards point of view. And I have the definitions on the slide, but let me give you a better example of it. In my day job at AT&T, I manage a team of engineers that's responsible for developing the standards for LTE and future technologies. As part of that, we get to travel the world and go to standards meetings, 3GPP standards meetings in all parts of and all regions of the world. One of the benefits of a standard is when they go to those meetings, I can still get in touch with my staff because their devices will work when they take them into different regions. And that's because they're using devices that are based off of a 3GPP specification. And it allows roaming, or in the broader definition, interoperability through a variety of networks in the world. The global standards helps ensure interoperability. It's part of the 2G, 3G standards that exist today, and it's being built into the 4G LTE standards that we're currently developing as well. If we look at the LTE ecosystem, it's built upon the GSM UMTS family of technologies. There's over 25 years of experience in there, 840 networks in 192 countries. The economies of scale, we've got interoperability through 4 billion connections according to the GSM Association today. There's a diverse set of handsets out there, common network interfaces, and as already mentioned, roaming in upwards of 190 countries throughout the world. And this is all through a set of standards that are developed in 3GPP, as well as an association called the GSM Association, which is responsible for developing specifications and interoperability guidelines. There's a number of groups within the GSM Association that works to account for things like billing, interworking, roaming and LTE, and security and fraud, which is another big issue. One of the most recent additions is the ability to exchange data in real time between networks. It's called Near Real-Time Data Exchange, or NRTDE, in order to help mitigate and prevent fraud. The process is in place within the commercial networks to address interoperability. Within North America, we do have a regional interest group of the GSM Association looking specifically at North American issues, as well as the ADIS North American Standards, which is the organizational partner for 3GPP. With that, there's the ability to leverage services, leverage the commercial networks that are out there today. Roaming and interoperability is just one part of that. Through the ability to roam and interop with the commercial networks, there'll still be the access to services that the public safety will need for their mission, for their particular mission. You can use different methods of routing traffic back to home networks or through the visited network, depending upon what model you need to offer those services. The public safety broadband is just another LTE network to interoperate with in the whole scheme and realm of LTE. When we talk about system identifiers, AT&T has a history of system identifiers and what to do with PLMN IDs. We started, AT&T was a collection of a different number of companies, acquisitions, mergers, and so forth, and we had a large number of PLMN IDs when we started out. Over time, we shrink those down to just one PLMN ID to manage the networks easier in a more convenient fashion. Everything from the back office OANM, charging and billing, provisioning, security and fraud, roaming agreements and settlement, and multi-jurisdictional roaming. Really helps when you have a small number of PLMN IDs. PLMN ID also facilitates interoperability and leveraging of commercial services and the use of a policy architecture and policy control functions within the network allow you to differentiate services between operators, between public service and commercial. And you will hold the questions off to later, but in summary, the standards that are being built for LTE really focus on interoperability, as that's the core of the GSM family of technologies since they've been evolved. It's to support interoperability, roaming throughout the world on a global scale, and support multiple network interconnections. Thank you.
Thank you. Dennis, you're next.
Good morning. There were three words that Admiral Barnett used this morning that I want to echo, because that really is the theme of what we want to talk about in the next few minutes. And those were architecture, governance, and policy. What we've learned, if nothing else, over the last decade of addressing the interoperability challenge in public safety is it's not simply a technology problem. It isn't simply a governance problem, it's really the combination of the three together. So we'll use that kind of as a framework for our discussion today. I think it's useful to kind of step back and say, well, where are we today, and where is it we're going along this journey, and what are the steps along the way? If you look at today's situation in public safety, we really have a bifurcated scenario. We have mission-critical voice services delivered over LMR, level radio technologies. It is the core network today, so to speak, core technology today in public safety. And that augmented with carrier data services, which are really the backbone today of the data applications that are used in public safety. That's the world today. Those are two very different worlds. Not only is there not interoperability among them, even within those domains, there are degrees of interoperability. Where we're headed in the future really is this converged network. Our mission, our goal really is to define and develop a nationwide network built on LTE technology. We want to address mission-critical voice and data as the core primary support capabilities. We want nationwide roaming. We want this network to be, and must be, public safety grade. If we fail to achieve that one component alone, then we will not have succeeded in delivering a mission-critical system for public safety. And ultimately, interoperability with relevant technologies as this network converges. In the middle is, how do we get there? So we view that there will be this interim period of development and deployment of an LTE network. There will be an interim period where we will require some level of interoperability with legacy systems. We believe that same thing is going to happen on the data side. There will need to be a period of interoperability or roaming between the current systems used by public safety and this converged LTE network. With respect to the solution, it's useful to kind of look at it top down. The whole solution as a vertical solution has different components. The core, of course, is the LTE network itself. That is where we're going to enable interoperability. This is something we must get right from the beginning. We must develop a nationwide network that supports nationwide roaming across all of our jurisdictions. But in the end of the day, what really is interoperability about? It's about the end user. Interoperability is ultimately the experience of the user, and that's going to be experienced on the edge of the network. The user devices, the network services built on top of LTE, and ultimately the applications that are deployed. One of the topics we'll discuss in the panel session is, how do you measure success? How do you measure whether or not you've succeeded in interoperability? And the answer is, it's in the user. It is the user's experience. Ultimately, that's what's going to determine whether or not we've succeeded. It's useful to talk about different domains and addressing how we achieve interoperability. So we've kind of taken that same top-down approach, looking at the different components of a vertical solution. And in each of these areas, in radio access, the NPRM goes a long ways towards addressing what are the things we're going to need to do to develop an interoperable network, what happens in the backbone and in the interconnect of the different systems, how we provision the network, so on and so forth, and ultimately in network services and applications. I will say that there is a gray zone. There is a gray zone in what level of capabilities are going to be enabled at the services layer and what are going to be enabled at the application layer. The LTE as a standard, of course, focuses on the core transport and services built on top of that. It doesn't address the application space. And ultimately, in public safety, it is about the application. It is the mission-critical application that first responders are engaged in. And so as we think about interoperability, we will enable it in the lower layers of the network, but we must address it ultimately long-term at all layers of the architecture. To that end, it's useful to think about a template for constructing this interoperable network of networks. As we now see policy emerging, we are looking at an architecture comprised of regional networks with nationwide roaming across these networks. So it's useful to say, well, in that architecture, what do you do at each layer of the implementation to ensure that we're achieving interoperability? So at the RAN level, we believe, for example, there's scope that we need to undertake in the regional networks and scope that we need to think about from the national perspective. And we can think about that from the backbone, the core, the network services, and ultimately the applications. So we offer up here a template on how to think about achieving interoperability on a nationwide basis and how to think about doing it in the context of a network of networks. You know, the carriers have succeeded in a huge way in achieving interoperability, as one of our panel members has spoken. And they've done so because they've developed a network. In some cases, they're networks of networks, but largely they're a network. The challenge we're going to face in public safety is we're going to deploy a network of networks. And how do we ensure that those networks of networks achieve the same level of interoperability that has been achieved by carriers is our challenge. We think that the tools are there to do so. It's an issue of defining the architecture, creating the policies around it, and establishing the governance structure that's going to make this possible. Thank you.
Emil, you're next.
I guess I get the back cleanup. I don't mind that at all. Good morning, everyone. I want to first of all thank the Public Safety Homeland Security Bureau, Dr. Ghaffari, Emil Barnett, Jennifer, Pat, I saw you back there somewhere, Jean, for giving me the opportunity and giving our program the opportunity to present before you. A lot of familiar faces today, so most of them friendly, I hope. And I think this is key for us to discuss with regards to what our program is trying to do in conjunction with the FCC in being able to test LTE as a technology and make sure that it is interoperable the way it's advertised as and meets public safety's needs. So I work in Boulder, Colorado at NIST, and one of the things that we're doing is taking the thought leadership and that the FCC has taken in advocating and promoting LTE as a common technology and utilizing that in our labs and testing that with the vendors. And so we're very much looking towards what the commercial world has done. We've seen what's happened in land mobile radio in the past, and when you start veering off a commercial technology, you lose all the benefits that come with that. So utilizing organizations like 3GPP as a standards organization, GSMA that was mentioned by Brian earlier. It's one thing to have a standard like LTE that has specifications for different nodes in the network, how they interconnect to each other, but each one of those are implemented differently by every single vendor. And just because a standard is developed doesn't mean that everything in that standard is put into a box. So for instance, 3GPP Release 8, December 2009 release, I would venture to say not one vendor has deployed and developed every single feature available in Release 8. They just don't do that. They do that based upon the needs of the vendors, the carriers, their customers, and what they request. So being able to test those different implementations against each other is key. How they get implemented then, 3GPP really doesn't define that. Organizations like the GSM Association go into great lengths on how to define interoperability between the different nodes, define roaming interfaces, testing, things like that. They have what they call IRs, industry requirements, above and beyond what 3GPP has and how you define and integrate those in. the representative into 3GPP, ADIS. We participate in that. And ADIS has some other roles. PLMN IDs were mentioned by Brian. The IMSI Oversight Committee manages PLMN IDs for for North America, actually. So understanding how critical allocating PLMN IDs, mobile country codes, mobile network codes, in addition to how the IMSIs get divvied out to public safety is key to interoperability. So working with ADIS as an organization and public safety working hand in hand is very crucial to that. On the subscriber side, following what the commercial side has done for ensuring that RF protocol and conformance testing is done to ensure interoperability, organizations like the PCS Type Certification Review Board, PTCRB, are very useful because they're existing fora that already do testing in an open forum that all vendors have to meet. So if you're a subscriber manufacturer, that's the minimum specifications that you have to meet in order to be interoperable before you even sell a device into a carrier or to public safety. On the flip side, on the infrastructure side, there's very few places where you can do interoperability testing. So one of the organizations is the Multi-Service Forum that we're looking at right now and utilizing their interoperability test plan that they have for Evolved Packet Cores. And the reason this becomes so crucial is that for public safety, we're looking at, as Dennis mentioned, a network that is going to have multiple vendors in it. And when you have multiple vendors, there's multiple interfaces that get implemented in different ways. Ensuring that those are tested and that they work with each other for mission critical data and voice is key. And so because of that, that's why we're bringing in every single vendor that we can into our network, testing them against each other and trying to advocate that for public safety and present those results out. The other thing to understand, and this is continual, that just because we test on release 8 doesn't mean it's good and you ship it out the door. As new bug fixes come out, new feature releases come out, release 8, release 9, release 10, release 11. Release 11 is being worked on right now in 3GPP. Release 8 is considered legacy and we haven't even put anything in the ground. So that's how fast the standards are moving. So in order to keep on top of that, we need to continually update our testing regimens and ensure that we have interoperability on all sectors. That includes applications, utilizing common APIs like the GSM1 API to ensure that there's commonality in the system, but allowing flexibility also for development of new features. This is not to be draconian in any manner, it's to ensure minimum operability in the system, therefore ensuring interoperability. So as new hardware platforms are deployed in the network, as we go to release 8, release 9, there's new feature functionality that will get deployed. We want to be able to test that continually in our network to ensure that public safety has what they need in their network. Typically these issues are addressed before you roll out a network. So I'm glad we're meeting now discussing that. The reason is you want to reduce the amount of capital expenditures that you have on this network. There's been a lot of talk about funding this network and how much it is, but in the end, that's potentially a one-shot deal, and we need to get it right as best we can the first time. So preventing stovepipe solutions, preventing de facto standards that get implemented, and trying to determine what the issues are, work those issues out with the particular vendors and with public safety before we deploy the system, I think is imperative to ensuring interoperability. I thank the Commission.
Thank you. Great presentations. So are you panelists ready for questions? All right, let's start. Since architecture is one of my favorite topic, and Dennis touched on that, so my first question goes to you, Dennis. The nationwide interoperable broadband network has evolved over time to fully meet public safety requirements. What would be a roadmap for this evolution? And I know that you touched on that on your presentation. Maybe you can elaborate on that a little bit more, but do you support the development of an architectural vision for this network? Or it should be evolved as needs arise? I mean, should we let it go or just we should do something about it?
Great, thank you for the question. I think it's pretty clear that a complex network like this probably isn't going to evolve through its own natural processes. That there has to be a governing structure around development of the network, or it will not come into play. So I believe that three things need to happen, and Admiral Barnett touched upon them. We must have an architectural vision. And the fourth NPRM, the current NPRM that's out, has laid out a lot of the questions that are relevant to that topic. And so we all need to do our due diligence in responding to the current notice of proposed rulemaking. I think it sets a great framework. So the first thing is, yes, the vision. The NPRM is a great framework for casting that vision in terms that we all can come to grips with. The second thing is the governance structure surrounding that. ERIC and the ERIC PSAC are great steps along that direction. We think those two organizations are going to be pivotal to implementing the vision that will be put forth in the fourth NPRM. And then finally, the policies that surround it. There are many topics, and I believe ERIC will also be a great forum for addressing the policy issues. Quality of service, priority, and preemption. Those are hallmark capabilities in public safety networks. And what we find in practice is there is regional variation on those two topics. And it is frequently local governance and policy issues that dictate implementation. We advocate for some level of regional flexibility, but yet consistent with a national framework.
Any other panelists have anything to add or comment? Or?
I would just say, from a architecture standpoint, looking at the needs of public safety that may be above and beyond what a commercial network has or entails, things like a multicast broadcast that a typical carrier wouldn't deploy, putting those in the roadmap of developers that are developing infrastructure and devices is important to do, and to have that, and for public safety to take a leadership role in that. So I think there's technical features that public safety needs to advocate for, because those are typically long lead times, maybe multi-year type of endeavors that public safety needs to get on top of and in front of, because otherwise it just won't get developed, even though it's in the standard.
I would say the other important reason to have an architecture and to do this work from the beginning is not doing so risks a balkanization of, depending on which vendor built whatever network, you might have different architectures, different standards. If you don't crack that stuff from the beginning, you will not have the level of interoperability and the vision of interoperability that this whole proceeding has been based on. I think Dennis put it very well. Thank you.
Okay, as you all know that in the third order, we adopted LTE as for the air interface and the core. And my next question is for you, Emil, that are there other technologies to complement the capabilities of LTE to address public safety requirements, and in particular interoperability?
So I guess these are in conjunction with that. There's a lot of talk by public safety for voice services to be deployed either as an adjunct or an eventual replacement for land mobile radio potentially. So voice over LTE is the telephony-based voice solution, not a push-to-talk solution. But that's being advocated in GSMA, not in 3GPP. So that's something that complements LTE in the standards process. Transport mechanisms like IPX to have secure transport between packet core networks to ensure quality of service. Utilizing that, and again, that's managed primarily in the GSM Association. Some of the over-the-air provisioning aspects for mobile devices for secure updates are managed in the Open Mobile Alliance in OMA. So those are additional things. There's also licensed technologies that potentially could help public safety for push-to-talk type services without infrastructure that are not LTE based. There's products out there that allow point-to-point communications that are not LTE but can meet the needs for public safety. So those may complement, again, a public safety device in meeting their interoperability needs.
Yeah, please.
Probably the largest gap that exists today has to do with off-network operations. In public safety, we call it talk-around. It's the ability of a first responder to communicate locally without the presence of a network. That could be part of a standard operating procedure, as it frequently is in the fire service, or it could be part of a scenario where an infrastructure has become impaired, where off-network operation is required. This is not currently in the standard. There's no significant progress being made along this direction. We believe this is an area where we're going to have to develop interoperable technologies to augment the standard.
Going back to what Emil mentioned about the voice, the voice component is fundamental within LTE technology and defined in 3GPP standards. What is lacking is a common set of profiles on how to take the full set of LTE standards and define a voice profile that can be implemented in devices. So what the GSM Association is doing is developing really an implementation guide, looking at all the different options in the standards and capabilities of the standards, narrowing them down into a common set of functionality that will provide voice services. And standards is just that. It's a set of specifications with many options to choose from, and without a common implementation guide, that's one way to ensure interoperability, is to make sure you've got a common implementation across networks, and the GSM Association does a good job at that, at developing these implementation guides, voice being one, definitely. And also, as mentioned, there are other components into the standard besides what's 3GPP is developing. The Open Mobile Alliance is really looking at the service layer, application layer, developing APIs to get new services into the LTE ecosystem, and looking at regional standards from the Alliance for Telecommunication Industry Solutions in North America as another aspect for getting more regional-based solutions.
I think NIPSTIC did a great job a couple years ago putting together the basic set of requirements for this public safety broadband network. And one of the starting points was looking at it from a user perspective, looking at what types of applications should be supported on that network. And there's a nice list of applications there. And as you look to that list of applications, being able to get onto a web page if you roam into a jurisdiction, or being able to send a short message service message to alert people, voice, VPN access. All of these applications and services require something above the basic LTE standard to be able to make that work in an interoperable way and bring that type of communication and the power of that communication to the first responder community.
Now that we touched on voice, I'd like to direct this question to you, Brian. What is the range of services to be offered for public safety? Are they to be provided locally or nationally? I mean, that of course may include voice, not that today, but in general, I'm asking about services for public safety.
Yeah, LTE provides a flexible network architecture. It's an all IP-based network. It has what's known as the IP Multimedia Subsystem, or IMS, as part of it for managing the service environment. So my question would be back is what services are needed? They can really be built at the application layer on top of the IP networks. The hooks are in place within the LTE network to give a large flexibility of services that could be offered. Emil mentioned the MBMS is one. That's an integral part of the standard. There are other components with the standard to manage the QoS and policy functions, select different bearer characteristics that are needed for different service types, whether it be a non-real-time service or a service that requires a guaranteed bit rate with real-time capabilities. There's full flexibility at the lower layers. So I would challenge it. What APIs are going to be available to provide the services up at the upper layers that that can ride over the IP transports. It's wide open at that point.
We look at the evolution of the current capability set. The common practice in public safety today is for a public safety jurisdiction to purchase data capacity from a carrier and then build an applications environment on top of that. And largely it's been done on a jurisdiction by jurisdiction basis. It is applications driven, it is not services driven. So it hasn't been designed as a collection of services that are then leveraged across jurisdictions. That has not happened because they've been developed primarily in narrow jurisdictional applications. So that's something we have to look at, which is the evolution to how much you push from the application layer down to the services layer and how we standardize them. The second is there are a very wide and vast set of capabilities required in day-to-day public safety voice communications. We have spent 2 decades developing standards in APCO around the user-driven needs for voice and voice-related services. We have to learn from those experiences, because that is what is in use today. There are certain expectations that public safety users have today that those standards were in fact designed around. So we have to understand where did they succeed and where did they not succeed. What do we leverage and what do we not leverage? So I recommend that we do look at that.
So yeah, public safety response today is no longer jurisdictional and local, and the events of the last decade have shown us that. It requires information sharing across jurisdictions, across states, across agencies. So in order to make this technology useful for that type of response, there are components you absolutely will need nationwide interoperability, nationwide services for. Now, there may be some local applications that are using those common services that are available nationwide, that are used to build specific applications for local areas. But in terms of the network functionality, that should be something that is available everywhere, because the public safety response today demands that. One
quick comment. In addition to applications, which has been primarily the talk about here for services, I think some of the services that we're looking at potentially are SIM card provisioning, having a common SIM card provisioning, having common authentication and encryption technologies for key management nationwide. In order to do that, billing, clearing, those roaming type interfaces, those are services that aren't necessarily an application, but they lead to interoperability, and you need those things, and those could be and probably should be common amongst all networks that are deployed.
Yeah, I also want to emphasize that, public safety isn't this monolithic thing. If you look at the 3 branches that make up our first responder community, law enforcement, fire service, and EMS, they're very different. Their missions are different. They have different mission requirements. And so what we'd like to see is that we address also across those different mission requirements how we develop and apply standards for interoperability, but recognize that their missions are really very different.
Thank you. Well, Ken, since you're sitting next to me, I'm going to get you the toughest question. But don't worry, I'll have the answer and can show it to you. So, this is next question. How do you address the operation of this network? I mean, by this network, I mean this interoperable nationwide network for public safety. How do you see the local needs of public safety versus the nationwide interoperability requirements? Do you see one network, one operation, or many networks, many operations, or something else?
I think this is a
tough or not?
This is
All
tough,
right, so
but
go
I
ahead.
also I won't. These are questions that are best addressed in a group setting. So there are some absolute benefits to building larger networks. Not building a 2-site network in a city somewhere. There's when you look at LTE, you look at the economies of scale, you look at the costs, you look at also spurring the ecosystem, people to build devices and build networks, amassing the buying power on a larger scale that's the kick that gets the whole system moving. So there's benefits in terms of interoperability, in terms of also getting the right focus on building this nationwide network when networks are built on a statewide basis or a multi-statewide basis. So operationally, you can build that network in a way that the actual, we're talking about the transport and that type of control is some of that is partitioned out so that regional jurisdictions have control over who has access to the network, prioritization in an incident, being able to change the way priorities are managed and applications are handled. So it's not an either or. I think it thinks that you need both, but moving to a larger scale than what we've had in the land mobile radio world, I think is a positive step. It is what creates interoperability, and also maintaining that interoperability going forward, year on year on year on year, as new releases come out, new devices come out, new applications come out, absolute necessity.
Please.
If you look at the AT&T network, we went through that exact same exercise, and what we ended up with is a common core network for our nationwide network across state boundaries, across major cities. There's many benefits to looking at a common core, common IMS. You might ask, how would you manage some local jurisdictions? Well, you can develop a standardized interface into policy control functions, into provisioning interfaces, and manage at the local level through those interfaces, yet have common functionality which would support interoperability across the nationwide network using a common core, common IMS, maybe in a common IP backbone.
Any other comments?
You know, in public safety, perhaps the greatest fear that a firefighter or officer has is they're addressing an incident, and the network that's servicing their incident is 3 states away, and for whatever reason it isn't available. So we must understand the mission of public safety. We have to do both. We're going to have a network that has the scalability for standards and supports interoperability. That's a must. You cannot build LTE networks to scale on a small basis. It just won't work. You won't achieve nationwide interoperability. So there absolutely has to be a component of the network in its implementation and its policy and its governance that is indeed nationwide, and operations for that matter, certain components of operations. But there will need to be components where there is some level of regional
Do you suggest that it should be a balance between the ease of operation and the public safety needs?
There should be a balance. I don't think either extreme is going to be useful. We have to render to Caesar what Caesar's. There are some things that we need to do on a national level. So in the template I described, we looked at the architecture and said, look, in each architectural component, what components should be thought of on a national level, and what components should be thought of at a regional level. There are certain components in the packet core itself. There's no reason for a packet that's going from one city in one state to another city in that state to go to California first.
Yeah, I think it's very important for parties to file in the record, because FCC, when we look at all these pros and cons, to just make that balance, see that.
So again, I think looking
that's
at
very
the
important for us.
and then looking at the national versus the regional component of it, both from a technical and implementation side and the policy and governance side, and let's dissect it in that way.
Okay.
We support a multi-regional approach. Gives you that flexibility, allows large jurisdictions that have the ability to run the network, have the funding to run the network, to run a network. It gives the flexibility needed. Ultimately, it's a question of governance and funding. Ultimately, probably two main ingredients, and ultimately what the user requirements are. So most funding today is administered at the state level. There's not a lot of, there is some sharing, but it's those things that are the impediments to building bigger across states and jurisdictions.
So, now that I asked some question on the architecture and architectural capability, I have more question. I want to shift the question a little bit to some other areas, which is open standards. My next question is to Dennis, actually. In the third report and order, LTE, which is a commercial technology standard, is adopted for both the air interface and the core. My question is twofold, basically. Should there be additional measures to adopt technologies that employ open standards, and if so, what should those measures be? And the second part of this question is that, do you fully support the adoption of open standard in developing this network?
So over the last year or so, the Commission has engaged in a series of forums like this, a series of rulemaking initiatives, and so on and so forth. And I think the unanimous consent pretty much is that LTE was the right technology to build, to use as the basis for the network. That's almost as close as you get to unanimous consensus. And so we recognize that is a great starting point, defining the network itself, the core network itself. As we've discussed earlier, on top of that network, then is where the sort of the meat lies, the services and the applications. So I would say yes. We having built on the LTE standard, now we've got to look at standardization across the other layers of the architecture, because ultimately, if we don't do that, then yes, you can exchange packets nationwide, but you can't exchange content nationwide. You can't access criminal databases or other mission-critical data sets. So I would say yes, there's going to be a need to further develop and enhance standards that are mission-specific, the services that go along with those, and again, once again, off-network operation. We need to address that.
Okay, go ahead.
I mean, if your vision of the world for public safety is, regardless of application, regardless of area, regardless of jurisdiction where that person came from in a response, needs to send a video. It's the highest priority video. It's got to preempt what's going on. The local incident commander has decided that that's what should happen. You need the level of open APIs and services that Dennis was just talking about. You need to be able to, LTE is not enough. You need that extra piece. You need the common standards, you need the common operational frameworks, you need the common scenarios, the common architecture. That's the only way that happens. And if you look forward and you want to create a view and vision of the world that supports multiple devices, multiple applications, multiple vendors, and the type of competition that has been lacking in the land mobile radio market, that's how you do it. That's how you do it.
Okay, I'm going to flip the coin and ask this question a little differently to Brian. Ready? Okay. What are the potential dangers to interoperability associated with the use of devices and equipment that employ proprietary technologies? So far we talked about open standard. Now I want to know what is the danger here. How do we ensure that any such use does not negatively impact nationwide interoperability? Well, everybody said open standard is good, but should we allow the proprietary technologies to be used? I mean, because some vendors and service providers may say that this is value-added features and capabilities. I mean, just give us some elaborate on that.
I think you hit on it when you said interoperability. What are the dangers to interoperability? And that's exactly it. Bringing in proprietary, non-standardized devices, protocols into the LTE ecosystem, you run into the danger of disrupting the ability to interop according to the standards. Emil mentioned testing as a key component to ensuring interoperability. Well, if you bring proprietary devices in, now you have to develop a whole set of test suites around those proprietary devices, and you have to test those devices against every vendor that would be possible deployed in the LTE network. So a proprietary at the device level does bring in significant risk of disrupting the ability to interop freely. Now, at the application layer, though, when you talk about developing applications, proprietary applications, there's a little bit more flexibility there. But you still run into the risk of interoperability issues because you have to make sure everybody who's using that application test and make sure the application works with each of the other users of that app. If not, then you have the same risk of disrupting interoperability.
Any other comments?
I would just add on, you know, if you look at the iPhone or Samsung Galaxy, they use proprietary technology for their screens. So, you know, that, you talk about devices, that's welcome and open, I think, in this forum. When you look at the physical layer, call setup, bearer establishment, all of that is defined in 3GPP. I think that's a non-negotiable item in this network, that those items get tested and developed according to the standard and implemented. And I think a great example of this is the Verizon Wireless Open Development Forum that they created as part of their Band 13 deployment. They had developers come forward and say, hey, I have a device, or I have an idea of a device. They were able to innovate, develop their own device, but in the end, they had to be interoperable and meet a certain set of requirements in both 3GPP and Verizon test specs, open test specs, and test those openly and have the results openly known before they could even deploy or utilize their device on the network. Once they met that, then they were able to deploy, but it still allowed for innovation, but meeting a minimum requirement for a standard.
So Dennis, the way Dennis talked about services, I mean, services is something in the telecommunications world. We talk about these basic building blocks that applications use to be able to exchange information, talk, managing priorities, managing QoS, managing groups, provisioning devices. These are things that should be open and common. The differentiation can happen at the application, right? We have different email systems, right? Some people using Microsoft, some people using Gmail, whatever. it all works. And one of the reasons it works is that underlying service of how to send mail from one device to another, that's completely open standard, okay? Completely open standard. So this same analogy, that service layer guts, that is the critical piece to make this network interoperable and open up the wealth of applications that we see and making them useful for public safety and creating that interoperability.
Yes, just a quick follow-up. I mean, Emil makes a very good point. When I was thinking about proprietary, I was thinking more of the network access layer. But yeah, certainly, I mean, if you do a proprietary user interface and stuff, you know, that's different, right?
So we see some value-added things.
Yeah.
So it is. I think it's very key to identify those interoperability parameters that we should not compromise, and those be at the network layers and.
Yeah, I think Emil touched the core issue, which is we don't want to stifle innovation. The fact is that most technology is developed in a proprietary setting, and we don't want to stifle that. But we can't let that innovation become an obstacle to interoperability.
But it makes the life is very tough for us to figure out what are the key parameters.
I like the framework that my colleague here used, which is, you know, you would standardize the method of transport of email services, but you wouldn't necessarily standardize the user interface that delivers them.
Yeah. Let me give you an example of where
Okay.
it didn't work. Instant messaging. And I think we're all, you know, familiar with the lack of interoperability in instant messaging protocols, because there were several different protocols, proprietary protocols, and it took years to get interoperability embedded into that. So there's the opposite to the email.
Okay, so let me next to another topic. This is the topic of interoperability verification. That's what I would call it. The testing would go underneath that. So one question basically is that how do we verify that interoperability is achieved? I mean, yes, we talk about testing. Is there any other means other than testing that you folks can?
Testing combined with the hammer of the mighty dollar is a very strong incentive for encouraging interoperability. So testing, defining test cases, coming up with, so Emil talked about some of the testing that's done today to make sure commercial networks work. These are based on these test catalogs, stacks of tests, where, you know, it says, all right, this is what happens, and it's got to work this way. Vendors work together, do those tests, sign off, yes, it works. That piece is absolutely needed. The other piece that's needed is if it doesn't work, people shouldn't get paid for their equipment. Plain and simple. That's the dynamic that drives the commercial wireless network. That dynamic has to be part of the public safety network. And in terms of policy, driving that into the whole dynamic is essential.
Okay. And another key component would be, before you get to the testing, is develop a good set of implementation guidelines, similar to what's done, you know, for voice over LTE in the GSM Association.
Would that be a way of verification?
It's a way to get to verification, because you all have to be building to a common implementation and then test to that implementation to make sure you're all on the same playing field.
Yeah, the reason I'm saying that verification, because test is something tangible. You go and you can enforce it. I mean, something works or it doesn't work, right? But verification, I'm saying that if there is any other method, other mechanism that, in addition to testing, so, I mean, yeah, a guideline can be, if you can check it.
Testing is always anchored in requirements. What a test is about is verifying that you've met requirements. And those requirements are captured typically in a specification. So that goes back to how we define a national architecture. What are the specifications for it that we can therefore test? The fact is, if you can't spec it, you probably can't test it.
So I'm still going to ask my question on testing, and that goes to Emil. My next question. In terms of testing, where should be the focus? Devices or network equipment, or both? Probably both, but
I want my cake and I
what
want to eat
issues
it
should
too.
be addressed, and in what order? I mean, you have plenty of experience with this demo network. We have been involved in this. What is your overall assessment on this?
You really can't do one without the other. And so if you look at computer networks, everyone remember WANG, Unisys, Digital? That was before there are IP standards out there. Where are those companies now? They're, you know, you look at the open standards, open testing, and how that's made the market explode. One of the things, looking at the device side, if we separate the device from the radio access network, from the packet core network, on the device side, we spend a lot of time investigating, working with RAN 5 and 3GPP, who writes the test cases. They have a lot of test cases written for UEs and devices. That's what they're focusing on. We looked at the Global Certification Forum and the PCS Type Certification Review Board. We went PTCRB because they're North American focused, because the carriers get a voice in there and they control that process. So that's our recommendation going forward. In fact, we'll be in the meetings next week presenting Band 14 public safety to them in test cases. On the infrastructure side, it's a little more complicated. RAN 5 has not developed test cases for IoT for the RAN or for the EPC. And so, and it's highly unlikely that will ever happen. They haven't done that in prior technologies in GSM or in WCDMA. And so that's left up to the carriers to implement testing in their labs and to work with the vendors who sell them and make sure that they have their own IoT test plans. There are, though, a couple of organizations. There's the NV-IoT and there's the Multi-Service Forum. And so the Multi-Service Forum, we're looking at them at potentially doing a certification program for Evolved Packet Core IoT. They already have an IoT test plan out. That's getting, they've already had one plug fest already with Packet Core vendors, and that's, again, an open process to the members, so that multiple vendors, in fact, most of the vendors that are participating in the demo network are participants in the Multi-Service Forum. And the advantage of both of these organizations, PTCRB and MSF, is that we don't do a one-off from the technology. They have liaisons into GSM and into 3GPP, so if there's any issues, questions, concerns, those can be taken to those standards bodies and those organizations and worked out in there, rather than public safety spinning off into their own world.
Yes, Brian, please.
I think you touched on one key point, though, is that's not enough testing, right, from an operator perspective. We have multiple labs in our own environments where we run batteries of tests every time we get new devices or see changes come to our software loads for different components within the network. So testing is a crucial component. It's both, as you mentioned early on. You know, certainly we can't bring a device onto our network without having tested it first within our labs to make sure it fully functions and new features and capabilities are working properly.
Great. Yeah, go ahead.
I would say the burden of proof, 3 simple words: it just works, right? It just works from a practitioner perspective. It just works. It doesn't matter if it's vendor A, B, C, network, jurisdiction, Y, Z, whatever. It just works. And to get to that, it just works, testing, requirements, the policy, the funding, everything has to be there. And it's about testing and defining.
Thanks for that. I have more questions to ask, but I would like to open the floor at this point, and if there are questions from audience, please introduce yourself first.
Sure. I'm Harlan McEwen, representing the International Association of Chiefs of Police, and I also chair the Public Safety Spectrum Trust. A lot of discussion. Dennis mentioned it. Each of the panelists have talked about what is it we're trying to build here. Is it a network of networks, or is it a nationwide network? Dennis made the point that it has to be a balance of the two. I think it's important to, Bezad, of course you know, because we met with the FCC yesterday, to report that earlier this week, most of the major public safety organizations met in San Antonio and unanimously endorsed a strong preference for a nationwide network, not a network of networks. We're concerned about getting away from that concept and looking more at a single nationwide network, but a network that allows for certainly local management and control at incidents that gives them the access to the resources. Ken, you mentioned funding. Again, the second major decision on the group's discussion was that we have to depart from the funding process of the past. You can't have funding going to Chicago and New York and Los Angeles, and some get funding and some don't get funding. We feel there has to be a pool of funding that ensures that every piece of this nationwide network is refreshed and kept in sync and balanced. Otherwise, it'll be the old LMR system where some have, some don't have. Some systems will be up to date, some won't. You'll have a no interoperability right from the very beginning. So I just wanted to report that the National Public Safety Telecommunications Council and the SAFECOM Executive Committee had these meetings. We reported that to the FCC yesterday. That'll be in ex parte public documents that you'll see, tomorrow. So,
Harlan, do you have any question to ask? I understand it's a comment, but
no, I wanted to comment about what they were saying.
Okay.
Thank
Okay,
you.
Thanks.
I made my point, didn't I?
Yeah, no, you did. I was expecting some questions. Okay, go ahead.
I'm John Powell, and I'm actually going to be on a panel later this afternoon representing NIPSTIC. And following up on what Harlan said, first of all, when we go to a single network, it's no longer interoperability within the network, it's operability, and there's no roaming because it is a network. It's roaming if you go off to the commercial side. So a lot of those issues are resolved, but I was interested in the comments that were made. So what we're basically looking at is a shared distributed core. What we're looking at, though, is not to stifle those parts of the country that have the money now to do early build-out, the dollars in hand, BTOP or otherwise, including some local investment that's being made in Texas. And how do we move towards letting them start that and then eventually migrating that to a common national network so that we strand the minimum amount of investment in the process of doing that. Our reason for a national network, as Harlan said, is driven in large part by the cost associated with building out and the duplicative costs of building out individual networks, and then on top of that, all of the costs of tying them together, which if you start looking at the high speed connectivity that's going to be required in whatever form you put it in, is incredibly expensive, incredibly expensive. So
what is the question?
My question is, how do we take an initial individual build out and move it forward so that eventually we can combine it into a common core and not in that process strand the minimum investment?
Yeah, okay. I need to make a clarification that in NPRM, the current NPRM is, I mean, there are a set of questions, and these questions partly on the network of network architecture and other things that public can make a comment on that. So there is, at this point, there is no decision or certainty that this network would be a single nationwide network. So therefore, I mean, these are alternatives. I understand that. I understand your point. So with that premise, I think if panelists have any comment to make, please go ahead.
Sure. I'll start off, John, to try and address that. I think that's one of the reasons, the impetus for our demonstration network is to get early deployment there and to test out infrastructure, devices, all the interfaces, and test those out as soon as possible, as quickly as possible in an open forum, open testing. We're trying to push for that as quickly as possible. But as you know, John, all the waiver recipients that participate with us, they know that they're at risk. Whatever comes out in final rules by the FCC, they will have to, they being the waiver recipients, will have to either modify, change, update, whatever their networks in order to comply with that. We're very sensitive to that, and that's why we're very inclusive of the FCC, industry, and public safety in trying to figure that out. So, you know, we're trying as quickly as we can to do that testing that we talked about here prior, so that vendors know what's coming forward, what they have to meet as far as interfaces, specifications, testing requirements, things like that.
Any other comment? Question? This would be the last question.
Okay, it's great being the last question. I'm Dennis Roberson. I'm from Illinois Institute of Technology. And the obvious question that comes out of all of this, since we are now on LTE, common network with commercial side, what's the role of the commercial services in this? When we talk about interoperability, what interoperability should exist in commercial networks to allow for public safety to roam onto and be interoperable with those networks, and utilizing the great strengths of the priority access and preemption that were on some of your slides. How should that all work in your mind, and how should the testing fit to allow that to work?
Just any volunteer?
Let the service provider.
I think there's opportunity for the commercial networks to play a part with public safety. The thing to realize is, we are a commercial network. We have our subscribers that we are supporting on those commercial networks. So we need to look carefully at how to support the applications and the services that public safety would leverage off our networks, and how to incorporate those into our overall network topologies. I think you mentioned, priority service preemptions. There's a number of tools and capabilities within the LTE standards that could be evaluated as we look at different possibilities for handling public safety roaming traffic onto our network, and what services to support for those roaming subscribers. Go ahead.
I agree with what Brian said. I'll just go maybe to first step is devices. So having devices that are multi-band and multi-technology that are capable. If in the U.S. today, not every service provider is using the same technology. They're obviously using different bands. That's one of the first steps is a multi-band, multi-mode device that does support that level of roaming. So it doesn't matter where you are. If you don't have access to the public safety 700 megahertz network, that you can roam onto an alternative network. And if you look across the country, there's the battle of the maps among some of the service providers that also makes that a choice for agencies.
One quick thing to add, where service providers can get involved with us, they're the ones who have expertise in optimizing their system, knowing the parameters that they need to be set to in order to get the best performance, what key performance indicators to look at. In addition to leveraging backhaul, backhaul is probably the leading OpEx for LTE going forward. It's a huge thing. Being able to leverage that potentially in the future for a primary or secondary backhaul usage. Carriers have existing billing systems, user activation systems, call centers. Utilizing those rather than having public safety recreate those on their own, either through whatever mechanism is necessary, but leveraging that to the most extent so it doesn't have to be recreated specifically for public safety, I think are definite, easy, low-hanging fruit for carriers to get involved.
All right, thanks a lot, and that was a great discussion, and I really enjoyed and learned. I hope everybody else did, and this concludes our panel discussion. We'll have 10 minutes break until second panel, which is on RF issues and so forth. Thank you, and this is for our panelists.
Thank you.
Sure.
Especially good to see people come down from my home state of New York, and also see some people here from the West Coast. My name is Pat Amadeo. I'm Chief of RF Engineering, the Public Safety Bureau, Emergency Response Interoperability Center. And before we start, I'll ask the panelists to introduce themselves and give a brief input on their area of responsibility, if they could.
I am Jeff. There we go. I am Jeff Anderson with Motorola Solutions. I work in wireless broadband systems design in the Chief Technology Office.
Hello, my name is Mark Funke. I'm the Director of RF System Performance and RF Design for Verizon Wireless. My responsibilities include Washington, Baltimore, and the state of Virginia. Been in part of Verizon Wireless for 17 years and have worked in the markets of Pittsburgh, Boston, New York, and now in DC. Previous jobs included RF planning for the entire Northeast area, which included budget and RF design.
Mark McDermott, currently at T-Mobile USA, and I'm the VP of Radio Network Engineering and Product Validation at T-Mobile. Previously supported T-Mobile in some of the decision making around spectrum acquisition and evaluation, and have a background in RF and RF design, radio access network engineering.
Al Sadowski, IT Manager for the North Carolina State Highway Patrol and Department Security Lead for the Department of Crime Control and Public Safety. I'm an engineer primarily, but my mission is to support the first responders. We currently run the third largest LMR system in the world, and it's still growing. We used to have the largest private mobile data system in the world. And so data connectivity is the focus, and support to your families and you all out in the communities. That's my focus.
John Santo, I'm the Executive Director for Wireless Systems at Customs and Border Protection with the Department of Homeland Security.
Thank you. So this morning our panel will address solutions for deployment of radio access network, and this is the portion of the network that's closest to the mobile users or subscribers, and we'll look at ways in order to achieve nationwide operability and in turn achieve interoperability. So I'll have some questions for the panel, and we'll have a little dialogue and save some time at the end for some questions from the audience. So with that said, the first question is related to deployment strategies, and that's how we would ensure a minimum level of performance across the networks for a nationwide public safety broadband network. And I believe some of the panelists have presentations, so we'll start to my left with Jeff.
Okay, thank you. Get that up. Next gets it started. Oh, okay. There we go. All right, I would like to thank the FCC for inviting Motorola Solutions here to participate in this forum here. And as we look at the third rule and order and fourth NPRM, we really support all the design principles that are laid out in the document here, because it's been a result of consensus of industry and both the user community. We see that the order addresses all the major topics, interoperability. It touches on applications, quality of service, security, network-wide roaming, interoperability testing, and for today what we're going to drill down on is the very tricky question with radio networks is minimal levels of performance. Now when you look to go design a network, you really have to look at devices, applications, and economics in your design here. So we look at a mix of users having different operational capabilities in different parts of the network. Some networks are more dense than others due to the local policing or fire operations and other organizations as well. They may use different devices for those different applications. Some people may have simplified devices that are only text capable, or other devices may have full video screens and looking to provide video services. Some devices may be more specialized for two-way voice services or mobile data, in-car and vehicle applications, or certain emergency incident scene type of scenarios with specialized command vehicles. All of these devices have different characteristics that are optimized for the role that they play. And then when we look at applications, we touched on that a bit earlier. Although we have defined some of the minimal operable applications, we have not tied performance rates and quality of service rates to those. And those all become a set of modeling characteristics. And if we look to provide consistent operability across the network, we have to agree upon a common set of users, devices, and applications in which to design that network. Now, the industry has been doing this for years. Motorola Solutions has deployed approximately 1,000 systems in the last 20 years. And we realized a ways back we need a common methodology for designing these networks. And through The proceedings in TIA and TSB 88, there's 3 documents in the series that have been put together and maintained since 1998 to have common frameworks for recommending performance for systems, for how you model propagation and noise and interference limited systems, and how you go out and validate performance in the field. Because if the methods aren't the same, you'll get different results with different vendors or different communication tools or methods. So we feel that it's very important as we go forward on this broadband network to take the plethora of knowledge that has been documented in TSB 88 and wholesale. Most of it still applies to LTE. It's still a radio system, but we need to add the LTE specific performance parameters. Now with that said, something unique about LTE and its sophistication is the variability of performance. There's some significant variances due to different applications and different traffic loading that you see with unique customer situations. When you talk about the different types of devices, how the devices are used, whether they're worn on the belt, a telephone device that's brought up near the head, they have all kind of different performance characteristics. We look at implementation factors. Certainly, you know, you can read a lot of literature in the industry about LTE performance, but it must be applied to minimum specifications. And there is minimum specifications provided for both the radio base station and the subscriber units. So we need to take that into account as well. Something very unique here going forward with 3G and 4G technologies is the performance that is realized in the network is heavily dependent on scheduling algorithms in the base station, which are not specified. They are vendor implemented, and they vary over release and over time frame. And you know, one of the unique things that is a hot topic right now is when you're looking at cell average spectral efficiency or cell edge spectral efficiency, and they're inversely related. If we try to get too much throughput at the edge of the cell, overall sector capacity has to degrade, or vice versa. So there's a very delicate balance there when you put in your network and tune your network between those two parameters to meet your design requirements. So looking at this next table here, what we tried to lay out is a typical view. This isn't a specific customer, but the general trends we've seen on the large networks that we've put out. And the trends are that the networks are usually phased in over time because of the deployment cycles it takes to put those networks in. And they're put in different demographic areas to handle different levels of use, different types of applications, different user throughputs, therefore different design criterion for those different areas. And a lot of times that's to meet budgetary constraints, as well as perhaps product and feature and device and application rollout schedules. The other thing I think we need to understand here that was touched a bit earlier is just because it's in the 3GPP standard doesn't mean that feature or performance or that mode of, say, multiple antenna operation will be supported in first releases, and the maturity over time will increase both in the product sophistication and performance and in the ability to tune these networks, because you can do all this design you want to, but when you put the networks out in the real environment, you need to tune them and optimize them for the use that's going on in your actual network. So what we see here is on the interoperability goals here, we think the third order and fourth NPRM is pretty much on the mark. We need some minor changes there. And on the operability goals on this performance topic here, we need to very carefully weigh the deployment flexibility so we understand that customers are deploying in different geographies, and there's a lot of public safety requirements in rural and rough terrain areas that standard operators are not operating in as well. And we need to look at specific public safety applications and loading criterion when we design the network. So therefore, when we look at operability parameters for the network, we definitely want to have experienced based data and performance requirements that are based on real release equipment that we look at today, and then understand the capability of that equipment as the standards and products mature. We want to have a consensus with the public safety industry, and I think the NIPSTIC and PSST has done a lot of good work here. I think we need to involve them a little bit more on the minimum operability rates and tie them to the interoperable applications that they set forward, and the Commission selected as well as endorsed. And I think we need to have the flexibility for phased deployments with variable density, because that is traditionally the way these networks have been rolled out. Thank you very much.
Hey, thank you, Jeff. Mark?
As I come to you as a designer of a commercial LTE network, I'd like to bring to your attention a couple of things that we've learned through the LTE rollout of the Verizon wireless network. But what is unique about this particular section of the forum is that this is based off of RF. And it's the same across EVDO, 1XRTT, or LTE. There are certain minimum requirements that you need for cell edge performance, but the bottom line is this is just RF. So some of the things that we have to take into consideration here are that the principles of forward link budgets, adjacent cell interference, and reverse link budgets are the key components to designing an LTE network that will be used across the public safety and public forum. So with that being said, I think it'll be the key of this particular group to make sure that those established levels are adequate enough to cover both a urban environment as well as suburban as well as rural, and at that, each of those levels will require a certain amount of RF in order to support what is needed. The last key component to this is what you plan on putting onto these networks. For instance, video type of communication versus voice versus strictly just packet data can all have a different load and a different requirement based off of an RF need. Things like sectorized cells, omnidirectional cells will be key components to the design of your network going forward. Probably one of the most difficult things for commercial wireless providers to get around is in-building usage. Some of the public safety issues that you may come up against is you have particular in-building needs that may be needed. That also will drive the levels of RF that are required at the street level in order to provide you connectivity inside buildings. You may then have to look at things like distributed antenna systems in areas where you may have large concentrations of public safety. One of the unique things that I dealt with was I was in New York at the time of September 11th, and we dealt with the significant amount of public safety people that were actually at Ground Zero, and the requirement for that particular event and the quick rollout of necessary equipment by us was rather significant. So all of these things need to be played into your overall design. So to put a very high broad brush on it, there needs to be a starting point of a greenfield design. Once those are established, we then need to break that down into what we classify as urban levels of service, suburban levels of service, and rural levels of service. Now, once we've actually have finished with that level of criteria, the next process goes into optimization. Verizon Wireless has already done a significant portion of the optimization for LTE. We started off in our Boston market, and that entailed actually putting base stations in place, working through the issues of first level software or first office software that was given into the eNode Bs into the core to ensure that mobiles could connect. And as stated earlier, one of the big and most significant parts of that is the piece of equipment that you will be putting onto that network. That testing also took that into consideration. So from the device to the network to the core, that testing was paramount to ensure that we had at least a base level service. Once that was established and we felt that we had all of those particular components worked through, it then became a matter of deploying the macro network or the bigger, wider network throughout the country. Once that was done, there was optimization necessary in order to go to the cell edge, or actually within the edge, in order to ensure that we could meet a minimum level of throughput at different points throughout the network. We have been able to establish some certain levels of values that need to be met in order to achieve Verizon Wireless level of throughputs at the cell edge. However, one of the things that we would like to bring to attention is the issue of self-optimization, or things that can be applied to it. One of the biggest lessons that we've learned through the EVDO network that we've had in service for quite a while now is that it does evolve. And I think that your first level, or your first offer to public safety, is going to evolve as well. You're going to potentially look at providing simple packet data to voice data to video data, and these different levels of requirements based off of what you think you will need going forward will drive the design of your network. So it would not be a good idea for us to set those levels of optimization at this point in time, simply due to the fact that you will change, and what you put on this network will change as well. So I think the panel should pretty much take an open position as far as how that will evolve going forward. At this point, I'm done, so I'll pass it off.
That's great. Thanks, Mark. Thank you, everyone, and just want to thank the Bureau for this opportunity for T-Mobile and myself to address the audience and maybe offer some insights and some of the experiences we've gained at T-Mobile USA. And I have to hit this. Maybe there's my first slide. Okay. Shamelessly, I'm reusing a slide I presented last year. I think it's a useful slide in terms of walking through some of the elements of radio access network performance. Probably the first thing I want to mention and bring up is at T-Mobile, and I think we heard some of this from my fellow panelists earlier today, that we do believe that the commercial operators have can add a lot of value to helping public safety meet its objectives. And I'll certainly walk through some of that today and hopefully highlight some of those elements for you. But we believe that commercial operators can help public safety accelerate the deployment of this network and make it successful, in a public-private partnership. Probably the first thing I wanted to touch on was really sort of put a slightly different, cast a different light on some of the positions that have been presented earlier, and certainly my fellow panelists are talking about this here, is that the implementation of a mobile broadband network is not an endpoint or a fixed state. We've learned at T-Mobile USA that the deployment of our HSPA Plus network, which has similarities, although it has differences to LTE, and certainly with our experience with LTE in Europe through Deutsche Telekom, is that the mobile broadband network capability is evolving very rapidly, and I would hazard to say we've done more to change our service capability in the last 3 years than we had done to change the service over the last 10 years in our network, the previous 10 years. So just a huge acceleration of change on the network, and I would assert that public safety will see that similar dynamic as end users, frontline users of the network, demand new capabilities, new performance levels, and drive innovation. Now that's exciting in many levels, but it comes with some challenges, and part of the challenges, as we heard from the discussion earlier about interoperation, is maintaining the integrity of the service while we have legacy devices in the network with certain capabilities, and we have new devices with new capabilities, all operating in a common infrastructure. So that's been an insight that we've had. I would say one key insight I want to convey, and I think it's fairly obvious in the commercial operator domain today, is that the capability to remotely upgrade devices to ensure that they maintain their performance on the network has been a key development in our ecosystem. So patching isn't really the right term, but the ability to go in and modify the radio parameters, the radio performance of a device, to correct issues, to improve performance over time is a key capability, and it's going to be a key capability, I would assert, for the public safety network as well. Talking a little bit about the sort of opportunity around you know, the aspect of sharing infrastructure, and certainly my fellow panelist Mark mentioned this earlier, this aspect of ensuring we have the right radio signal quality on the ground at the right point is something that commercial operators spend a lot of time and money doing. We have selected over the years many individual pieces of real estate to ensure our cell sites are located properly and that we have a consistency of coverage that can deliver the kind of performance our customers expect and that is truly competitive. And real estate remains and continues to be a major challenge to ensure that coverage consistency and quality criteria are met. I would say that the opportunity really is for public safety to look at commercial operators as partners in finding the right real estate. It may be that the real estate selection is driven by coverage needs, it may be capacity driven, or it may be driven by other factors such as in-building. But the aspect of having access and building partnerships to leverage commercial real estate opportunities, I think, is an absolutely key factor to success. Looking towards some of the other aspects of opportunity with partnering, backhaul connections between the switching centers that exist in the network and the cell sites that carry the public safety network. Those backhaul connections historically have been fairly narrowband, often carried on copper or microwave links, which are inherently in today's context quite narrowband. What we've learned, and this has been the experience with mobile broadband across the planet, is that these backhaul connections have to be supersized to the extent that they can now carry tens of megabits, in some cases hundreds of megabits per second of throughput. We've had extensive experience at T-Mobile of developing a source of supply, many sources of supply, so we can have those connections installed and commissioned. And the economics of that has been a fairly significant challenge. So whereas 3 or 4 years ago, our choice for buying backhaul lay mainly with the local exchange carrier community and alternate access vendors, we have had to develop new relationships with different partners across the country to develop you know, a healthy supply of backhaul opportunities so that we can improve the price performance relationship of the unit of bandwidth on the backhaul. So what I want to do now, if I may flip to my second chart, and I apologize, it's a horrendously simple chart, but I think the significance of it, I think, is quite important. On the vertical axis, we're sort of showing the unit cost of backhaul capacity, and on the horizontal axis, network traffic through time. I think it's fair to say anybody who's operating a mobile broadband network today is seeing an escalation of traffic on the network that's been driven by user behavior and mass adoption of broadband devices, whether those be iPhones, Android devices, or the new class of tablets, mobile internet devices. And this is very exciting and very challenging. The rate of growth of traffic, I would assert, is going to be similar in many ways, although maybe not in absolute terms, on the public safety side, as public safety and first responders start to use their network and find new ways of innovating And I would say that the aspect of minimizing operating expenses and cost on the backhaul becomes paramount, because traditionally these costs are recurring. And this is not necessarily a cost that public safety is being exposed to on this scale today, but as we move to LTE and deploy broadband networks, this cost will become a burden. What we've had to do is build scale into our business. I think we've been quite successful in that at T-Mobile in terms of buying bandwidth at much more reduced price points as we buy more. So the green line at the bottom simply is showing the trend that we're now attaining, which is as we buy more bandwidth for our HSPA Plus service today and possibly an LTE service in the future, we obtain better scale of economy. The opportunity here is for public safety to recognize the partnering opportunity, to see that there are ways of operating this network at very high levels of reliability at much, much better price points at the same time. And I say reliability, ironic as it may seem, but we found that some of these alternate access vendors can provide higher degrees of reliability than the traditional copper plant, because in some cases, in some areas, the copper plant is older and less well maintained. Plus, we're seeing the traditional carrier base, the local exchange carriers, investing heavily in the upgrade towards fiber, not just for our supply, but for the supply of their business as a whole. So therein lies the opportunity. So with that, I just want to say thank you for the opportunity to address the audience, and I'll pass it to my fellow panelists.
Thanks, Mark.
I'll try to do as well here. First slide, please. Okay. You don't need to know who I am anymore, so which one next? There we go. Okay, disclosure. Bottom line in my case, I'm at fault whatever I say. It's not my agency, and not my parents' agency. That's the bottom line. So if you like what you heard, you can attribute it to me. If you don't like it, it's definitely me. I want to say thank you to Admiral Barnett and the staff. I also want to say thank you to everyone here who is trying to help public safety, and I really want to say thank you for those first responders that are out there today protecting our families and our communities. They've got a good mission, and I'm honored to be a part of it. From where I sit down in the country area, there's an elephant in the room when we talk about what's happening here. In the past, public safety has been predominantly, it's been the public safety entities and some communications providers. What we're seeing now is there's an elephant in the room, there's a third party in the game, and it's they dwarf the historical public safety players because they have all those other constituents, customers, and it's the carriers. This is basically my presentation. So, it's not the primary mission of public safety. IT is not. Office connectivity is not the issue. Our primary mission is first response to the public, and we respond in rural, tribal, wilderness, maritime, and park areas. Crime happens there. People have heart attacks there. Fires happen there. From where I sit, the cities always have a lot of capability because there's business drivers that take care of the cities. But there's people, there's citizens that need support in those areas. So I'm going to be beating that drum over and over again. The rural, tribal, wilderness, maritime, and park areas. Even with no IT connectivity, no LMR even, public safety still responds in those areas, puts their lives on the line to protect you and your families. Okay, so what's the need? An affordable capability with the future path, secure, reliable, scalable, all kinds of nice motherhood and apple pie things, but I'll accent again the coverage for those rural, tribal, wilderness, maritime, and park public safety first responders. So we talk about broadband design. Well, to me, design and architecture precedes deployment. And the panel was a deployment panel, and I'm saying, well, legislation and funding are going to have a huge impact on the network design. And I hear public safety grade of service, and I scratch my head because I think that's like if we asked 5 people, we'd probably get 25 responses. On the design aspect, though, I'm going to, in my own shoes, how many agencies, public safety agencies, have the wherewithal to do a network design? And the answer is not very many, particularly those smaller, out-of-the-way agencies. And so I am greatly heartened when I hear partnerships. I mean, to me, it is a perfect storm situation. So the partnerships I would extend beyond the carriers, but to utility providers as well. Because as the story I tell, my grandma Sally in a rural area that loses power, and her oxygen machine is no longer working and she no longer has heat in the wintertime, is just as big a public safety event as my cousin Pete having chest pains in the city. Deployment, despite what I'm hearing here, LMR is going to be around for a long time, and agencies are struggling with the build out for a lot of reasons. The people I support, they don't care about the alphabet soup, they just want something to work. And they have limited resources, staff to deploy it, staff to support it, but again, I'm greatly heartened. Partnership, I like the sounds of that. I want to remind everybody, because I'm not making an assumption, that most public safety people are field deployed when they're doing their real job. They're out there, and so mobility is important. And they need secure and reliable mobility. And I'm going to take it up a notch. It's not just the public safety LTE. It's not just carrier partnership. It's why not white space? Why not data casting? If they're all IP, why can't we have a convergence here, that perfect storm to support you and your communities and your families? And I want to reiterate, because I work with a lot of locals and federal and tribal and state, and they have no ability to do data today. None at all. They look at a system that we fielded 15 years ago that provides 10 kilobits, a party line for every officer in a county, and they look at it longingly. Can you imagine? You can't surf with that, folks, but you can do a license plate lookup. You can do a vehicle registration. You can look up, wanted, missing. So I'm greatly heartened. I want this data, broadband data, as soon as possible. I want to help you understand, besides the rural, tribal, wilderness, maritime, and park, that usually the responders in those areas have vehicles. So a handheld is nice, but let's not constrain our thoughts for the coverage in those areas, because they usually have a vehicle. It may be an ATV, maybe a truck, maybe a boat. Power is not an issue. We've got plenty of power. Weight and battery life are really not an issue. We can have multiple antennas. And the benefits of the height of the antennas, the size, the gain, the processing with MIMO, directionality, and nulling are all there. We've got the footprint, the space to do it. So bringing that together, I think we would really benefit with an integrated solution that's across not just public safety, but also commercial, white space, data casting, heck, Wi-Fi, satellite. Bring them all together and make them work for these folks out there. And we need to test it. I liked when I heard the testing, because the EMI environment on a police vehicle with strobes, the high current strobes today, has to be seen on a spectrum analyzer to be believed. And we do go to places that have a lot of transmitters, and so intermod is a real issue. And then desensing. It's a daily thing. Officers see it. They don't know it's called desense, but they see it. So these devices need to be able to work through this. It needs to be application neutral. If it works on the internet, it works. It must evolve. And again, the partnership. I really like the sounds of that. I like redundancy because we need it. And in our case, we use fiber and microwave. Tower sites do go down due to ice storms, hurricanes, tornadoes, and fires. And more than 2 hours of battery at a site is something that's needed at a lot of sites, let me say. So I'm not going to say generators, because maybe there's something better in fuel cells or whatnot. precedence and priority. I'm not going to beat that drum anymore. Everybody hears it. But I want to make a comment that security is a three-legged stool. I don't know how many of the providers have had copper stolen from their sites lately, but it seems like it's a monthly occasion for us. And enough said there. To wrap it up, need it at all levels, at all places, and we need it as a partnership so we can provide faster response, better response, secure and more reliable response, and an affordable capability. Thank you again, and I'd say that during this event, about 100,000 911 calls will be made and will be acted upon by first responders. That what you're doing here, thank you, because it's to help them deliver more capable service to our communities and our families. Thank you.
Thank you, Alan.
I'd like to also begin by thanking the FCC for inviting me here to speak today. I'm really encouraged, having worked in 30 years in federal law enforcement, I'm really encouraged by the momentum that's growing around this event, federal, state, local, and industry, towards a common vision, which I don't think I've ever seen this much behind the common vision in the past. I'm going to talk, basically provide a little background on Customs and Border Protection, some of our, how we use these types of communications, some of our current capabilities, and also talk to some of the applications we see in the future vision. That might help some of the technology framework discussions. In addition to some of the challenges, which I'm happy to hear many of the challenges we've noted, I've heard mentioned before by several of the other panelists, so that's a good thing. First, in terms of current capabilities, we have today 45,000 frontline uniformed officers at Customs and Border Protection. We have a mix of air and marine operations and officers. We have a mix of Border Patrol and law enforcement officers at the ports of entry. Tactical communications is a major tool we use to communicate and coordinate between those just internal components, and we also use the same tools for external interoperability. The other thing, for situation awareness at the front lines, for the ability to have command and control, we have many patrols that have single-man patrols in remote border areas. Life and safety is a major issue. So these communications are critical at CBP. I mentioned we have 45,000 operational users. We also support 10,000 immigration and customs enforcement agency users that are investigators and that are detention and removal officers. So one thing I'll mention is we have a vast difference in the types of users that we use the system with, and so I'll get into it later, but I don't think there's, on the device side, a one-type device. I think our application needs are a little diverse. I just want to talk a little bit about the complexities and the challenges we have right now in the infrastructure that we're using to support those tactical comm needs at CBP. One, we've got a large legacy infrastructure. It's decades past, at least 2/3 of it is decades past its useful life cycle. We've got reliability issues, and we actually have gone beyond secondary markets now, and we're buying parts off eBay in some cases. So reliability for these critical communications, life and safety, are a big concern that we have right now. Coverage. These systems were designed many years ago. Our traffic patterns, our corridors, especially in the border areas, change regularly, and we don't currently have the mission coverage needs that our mission dictates. So that's one big issue. Adequate encryption. We don't meet today's AES encryption requirements, so that's a challenge. Lack of capacity. CBP has grown significantly in the last 5 years. We've actually doubled our frontline offices. that's significant load on these systems. So we have major concerns with having to modernize these systems. So what's our near-term approach? Near-term, we're looking like most others to traditional land mobile radio to get us the immediate needs, the immediate obsolescence concerns addressed. We've got a project underway, and we're deploying these systems. But but some concerns we have with the current technology, as was mentioned here earlier today, we depend heavily on scarce and probably, if you look at what some of the current bills going out, probably shrinking VHF spectrum for our land mobile radio systems. When you talk about capacity and doubling the capacity, that requires more spectrum. So that's a huge challenge for our current projects that we're rolling out today. The subscriber devices, we're doing a lot of things that I think are good towards interoperability, but at the same time we're making the devices much more complicated for our frontline users. They respond a lot of times in emotionally charged operations. We're putting 500 or more channels in their hands. We're putting interoperability channels that they don't use every day in the back ends of the radios. It's very difficult and getting more difficult and more complicated for them to operate on these land mobile radio systems. Project 25 standards, I think the common area interface is essential and needed, but as someone mentioned earlier, a lot of us have already gotten wrapped into some of the proprietary feature sets because they were part of our base requirements and they weren't in the actual standard at the time. So that's been a concern. True federal interoperability, still a big challenge to us. We put in whatever we can using the tools we have today, but quite frankly, I think true interoperability as needed dynamically it still eludes us. Expensive. Our project to modernize just LMR within just CBP, $1.3 billion capital expense. That's huge when you think about it's only delivering voice. And it's only putting in place systems that look a whole lot like the systems that we're taking out, not from an architecture perspective. So big investment. It's a $3.9 billion 10-year life cycle LCCE. So that's a concern to us, and it's something that it's driving us towards trying to find a major change in the way we do business. I mentioned only provides voice. We have huge and emerging data and video needs. CBP spends a lot of money on other projects to put in air platform video to provide situation awareness along the border, UAVs and aircraft mounted videos. We've got tower mounted videos all across the border that provide us situation awareness. None of that information, none of that video can be pushed to our front lines. So as they move into an area that they're responding to, we can't even show them what they're heading into. We describe it verbally on LMR systems by voice. So that's a huge weakness. The other thing is we put a lot of money in development into applications, mission applications, federated queries, biometric IDs and checks, and the list goes on and on. We've got internal agency applications. We can't share those applications with our front lines when they're in a patrol environment. Even things like e-muster that tell them where the current threats are moving hour to hour, they have to get that described by voice. So the fact that we're going to spend $1.3 billion over the next several years and never address any of these critical needs that we have is a huge concern, and why we're looking for a better long-term strategy. Long-term strategy, we think it's very much the same as we're hearing here and this common vision that's been promulgated, which is to go to broadband solutions, mobile broadband solutions that have a tactical hardening or mission critical greater service capability. Devices, someone mentioned that we all have slight variations. I think that we need as much flexibility and variety in subscriber devices as maybe the public gets when they go into commercial wireless stores. I think one of the devices that we definitely need is to bring in one of the feature sets from land mobile radio, which is the direct talk around capability, non-network capability. I think that's been an essential requirement that our front lines has voiced. We need the ability to direct talk around when we don't have network access. This slide just depicts what we're talking about, but I just want to make the point here, really a simple point, that we think by moving to the commercial standards as we're talking about, one huge advantage is the ecosystem around the commercial devices that become then automatically or with very little variation brought into our now tactical environment. In addition, we'd like to see, like I mentioned, tactical radios, voice radios like we have today that also can operate on those broadband networks, which I think that's a piece that requires a little R&D today. I think it's close, and I think industry is doing a lot of good things towards getting that, but it's still something that I think needs to be brought into the picture. I think most of us have saw at the President's State of the Union address. He talked about the wireless innovation and infrastructure initiative. We're encouraged by that. I think that provides a whole lot of capability and really broadens this whole capability to a very robust thing to work from. I do think in our minds there's still a lot of policy questions in terms of how that ends up when you have that much larger public safety network. We still are unclear on what is the status of federal users, and I think ultimately that'll kind of hopefully get worked into it. Types of applications we envision. As I mentioned, we envision a Project 25 type two-way radio with talk around capability that operates over an infrastructure that's mobile broadband and up to the 4G LTE standards. We think that also that component off the network needs to have the capability to do over-the-air reprogramming of all the edge devices and configuration management of the edge devices. We think we need to get simple user functions at the other end. We can spend a lot for a lot of sophisticated features, but at the end of the day, the only effective features are the ones that people know how to use and use readily. And so I think on commercial systems, we see that there's a lot of user-friendly devices. I think we need to bring that into this environment. Enhanced talk group management. We think there's needs internally to have talk groups that are fixed and in place, but we also think for interoperability there needs to be the capability to dynamically provision talk groups so that multiple users on the network could be brought together when needed, and then for clutter may be brought back apart when not needed. So those capabilities should be there. For data applications, I just threw a couple of examples of biometric checks. We today in some of the remote parts of the border have 5 or 6 agents will apprehend, bring somebody 2.5 hours to just do a biometric check, only to go back to the border location and release certain individuals. So that's a lot of wasted productivity and time. I mentioned e-muster to be able to give real-time information to the front lines as to what's changing in the threat picture, federated queries, and the list goes on and on. I think every agency has their list of mission applications. Video, image, and graphic, situation awareness, blue force tracking, these are all things that we don't deliver well today that we think this is an opportunity to fix. In terms of some of the challenges we see, I think they were mentioned already, but seamless national roaming I think is critical. We don't have any, even our internal components don't have the same regional district boundaries. So wherever you would draw lines, you would start to cut off some of our operational groups right in the middle. I think today we see where that's caused us issues, and we're very we're looking for some kind of seamless, consistent experience where, you know, the operations, the feature sets, the configurations of the same look and feel roams across the network nationally, And I think that's something that would make this a much more powerful capability. Other technical challenges that we've identified is capacity needs are dynamic in terms of when we talk about right-sizing the backhaul, which came up earlier. One of the things is, I know we always think of the urban areas, but I think, like you mentioned, I'm actually more concerned in the rural areas. We have very desolate areas on the border that could be very sleepy and quiet for most of the time, and then we'll surge large groups of users into those areas. So if the backhaul, it's harder to size the backhaul from a economic perspective when you have a smaller user base to defer that surge over. So I think in urban areas there's a much larger user base. You have much more opportunity from an economic perspective. I'm not sure how we handle it in rural, but I think when you get into public safety, unlike commercial, you've got issues where mission needs are going to dictate you know, we need those surge capacities in those rural areas. Encryption, I was encouraged to hear someone mention some kind of encryption that could transcend the common network so that we could have interoperability, and that interoperability could include secured encrypted communications. The other big uniqueness, I think, between a public safety broadband mobility network and a commercial network is the ability to specify mission need coverage areas based on mission need rather than commercial market. I think that's a difference that we pose. I'm not sure how that gets maneuvered at the end of the day through governance, I guess, but the point is, you know, that's going to be a challenge. That's something we see as a challenge from the economic perspective. Again, I mentioned governance models and ConOps. I think in public safety, I think that's going to be required. Transition, graceful migration. That's another big concern. How do we get from where we are now to where we are, where we need to go? We talk about 4G LTE and we talk about a public safety dedicated network, but even the commercial networks that are rolling out 4G start off with hotspots. It takes years to build out the coverage. So there's hotspots and there's other networks. That could be a place where the commercial networks provide some kind of a, especially in the earlier, you know, first 10 years maybe, some kind of roaming between commercial and a public safety dedicated network, I think is essential in order to have any kind of coverage that we're going to require. And so some kind of a migration strategy I think is key, given that I think the transition period and the build-out period probably will go on for an extended period of time. And I think I'll...
Okay, thank you all for presentations. So I heard a lot of good things, and I think I have two questions to follow up listening to the presentations, and one is related to rural coverage and another one is related to network performance. So related to network performance, I was wondering, in order to have a consistent user experience across the network, how do you measure that for public safety broadband or LTE broadband? Are there some key performance metrics, or can anybody comment on a few of them? For instance, I heard cell edge data rate, throughput, is there signal interference to noise ratio? I heard cell averaging. So I'm wondering, can somebody comment on that area as far as some key performance metrics?
If I may, I'll kick off and then hand it over to my panelists to comment. So a couple of opportunities. One of the big ones, having a broadband connection to a device via LTE and other broadband technologies. It does allow for the collection of information from the device, and certainly any modern technology provides KPIs, whether it be the signal to noise ratio, which in some cases is reflected by energy per bit over noise or interference. And those KPIs can be geolocated now because the devices have almost universally got GPS in them. So that's one huge opportunity that's enabled here that maybe wasn't available before, that commercial operators are beginning to leverage, that could be leveraged well in a public safety network.
Thank you.
finer point onto what I think what you're asking for is, what depends a lot with public safety is going to be the type of devices that you put on the network. I've heard comments of cars with bigger batteries and multiple antennas and potentially bigger transmitters inside the cars. But the bottom line is that you have to engineer to your finest, smallest point, which you have to consider that to be a mobile device, right? So if we take it down to the lowest level and assume that any public safety person out there is going to have some type of PDA type of device on their belt, that's our starting point. In our network, we design to a certain speed at a cell edge. Obviously, that's something that we keep very close to the vest from a competitive perspective. But with that being said, what we've been able to determine is that at a ubiquitous coverage outside building is about a 105 dBm RSRP value for LTE. That'll typically translate in, and that has to be accompanied with a 1 dB SINR value. So again, just having downlink coverage is not the fine point. You must also manage your adjacent cell interference or adjacent interference that may be impacting the throughput on your signal, because again, if you don't do that, speed and performance will be sacrificed. Now, so that's your downlink measurements, and those are basically what we have seen and can communicate that that's where we're kind of working ourselves at. The next part of that is now with the PDA. You're typically talking about a device that has very low transmit capability, and on top of that could have limited antenna capabilities and things of that order. So again, the reverse operating path loss model that best fits that model is right about the 110 to 120 range. So again, when you have to be able to marry those two together. Now, I want to stipulate at this point in time that those values that I'm mentioning are strictly for outside coverage, on the road, maybe in a vehicle, and are basically set for that type of criteria. Again, I've heard comments about need for biometrics and be able to send video to the fringe of your networks, and most importantly, that becomes somewhat of a conundrum for you all to deal with. But when you add the in-building needs, first wall coverage, second wall coverage, third wall coverage, your need for coverage and forward link power begins to increase. Once again, though, reverse links need to be taken into consideration. So hopefully I answered your question.
Thanks, Mark. That was perfect. Appreciate that. So let's do one more question before we go to the audience, related to rural coverage. Heard some good things from Alan and John on the end over there. And how do we promote or ensure rural coverage? Alan, you'll probably want to comment on what the requirement may be, but I'm thinking along the lines of in the rural areas, is there minimum requirements, say like highways, interstates, connecting populated areas, something like that?
Well, I mean, I want to make a comment that the metric of performance from my case is the officers that come to me with complaints. That's my, so the fewer complaints, I know the better performance. One of the things on rural coverage and have agonized over it for a number of years is I understand about the starting point being the mobile device on the belt, but I would ask the question then, why can't the vehicle act as a relay for the device on the officer's belt? Is that a compromise? Yes, but if the difference is I get rural coverage in a well away from the normal infrastructure because I've got more power and I've got better antennas, what a wonderful thing for that officer and the community he's serving, because he can relay. Yes, he's using a PDA, but he's relaying through his own vehicle because he's out in the rural area and he has a vehicle. Now, as to where the coverage, well, certainly I would say you can look at it from a business perspective that the carrier is saying is where's the bulk, and I understand you have shareholders you have to respond to. my shareholders are everybody out in the community. And so I have a tough time saying this place is more important than that place. And I certainly have a real tough time, you hear me beating the drum, that the cities are more important than the rural areas. So what I'd say is, it's understood that build out is difficult, but I would say come to us public safety folks, because we do have infrastructure in rural areas, and the ones I've talked to, and I know I've talked with my leadership, we're eager to discuss a partnership, because we do have a lot of towers out there. And we're working with BTOP winners right now that are putting in thousands of miles of fiber in rural areas as a qualifier for their BTOP funding. So there's middle mile infrastructure out there. So I don't want to say let's go to the highways first or go to the towns first. Let's look at how much we can get by doing this partnership. Carriers, middle mile providers that got BTOP funding, public safety's tower infrastructure. Let's come together, and I think we're going to be pleasantly surprised.
Thanks, Alan.
I would just
John?
add to that. For a large part of our border environment, northern and southern, is rural area. And what we find, unfortunately, in terms of trying to provision things and leave them in place, that whatever part of the border we're very successful at through surge operations, the threat then moves. And so we continually chase that threat, and therefore the areas of putting coverage change fairly rapidly. The other thing we find is, and I think one opportunity might be through this WI3 initiative that the President endorsed, there's a big push also in there to get rural area broadband to the citizens. And we find that, especially in the border areas, the citizens are at threat. We had ranchers along the Arizona border that were, there was one killed recently, and they have no E911 services or even basic ability when they're out on the ranch to communicate. So I think these two might dovetail, and I think maybe bringing some of this to the rural areas for the citizens, we might be able to leverage and benefit from that.
Thank you, John. Alan. Let's go to the audience and see if there's some questions before we take a recess.
Hi, good morning. Keith Crestman, AT&T. And this question is for Alan and John. We're sensitive to the fact that when public safety anticipates roaming to a commercial carrier, you're interested in what level of priority or assurance you would have that you would have access or availability of signal. So could you each comment on your willingness to accept roaming to commercial networks if there were a functionality for data priority service similar to what you have today in wireless priority service?
I think I recognize that we would have to make some compromises in terms of the commercial access, and I do think that that's why I say part of a transition strategy, that ultimately the priority access needed would be in the public safety network. So this would be kind of a filler or gap filler or a transition filler, probably useful for all time. But I think what you just mentioned might be a good compromise, and that's to have the ability to prioritize data levels and therefore put our most critical communications, pay for higher priority accesses on those. I think that would be a good compromise position from my perspective.
I would echo pretty much the same, with the one addition that there would be the opportunity, if it was a major national level incident, that there would be a mechanism then that we could notch up the priority for the first responders, but understanding full well that we would have the case, a lot of interesting cases, so we would have to work together in a partnership of what it would take in order to make it happen. But I agree. Something's better than nothing, and compromise is not a dirty word.
A follow-up on a slightly different topic, if I could. So really for the first time now, with public safety having access to their own 700 megahertz spectrum being held by the Public Safety Spectrum Trust, you have the opportunity to own your own network equipment, even potentially rapidly deployable network equipment. So I'm curious again for Alan and John, how interesting it might be, or to what extent you see rapidly deployable, perhaps on, say, a vehicle the size of a Hummer or a large-scale SUV, four-wheel drive, that might access some of those remote areas. To what extent you see that as potentially part of the infrastructure solution for the officers, especially in the case of park, marine, et cetera?
In my presentation, I made the comment along those lines, and I'm going to say that most of the agencies, we have to be carefully select the agencies who would own such equipment. There's a lot of agencies that are very small. The percentage of agencies on the law enforcement side that are fewer than 25 is a considerable, 25 sworn is considerable in this country. There's a lot of the fire departments are volunteer. So when we're putting very high technology out there and saying it's owned by public safety, I think we all need to recognize that it's not going to be just any. There'll be few, and there need to be partnerships there, because we may have to deploy outside of a normal operating jurisdiction, and there's issues there. Not to say no, not to say heck yes. I'm saying that, let's sit down and discuss it and work through it, because the bottom line is we need to support those responders out in the communities.
Yeah, I would agree totally, but the only thing I would say is while I think we definitely would want the ability to have deployable augmentation when needed, the only word that I'm not too comfortable with is own. I think one of the problems we have today, and why it's so expensive the way we do business, is when we own something, then it serves just our own internal needs, and it's the most expensive way to do it. And then we need a whole ecosystem around it to support it, maintain it, operate it. I think we today buy satellite services to be deployed when needed from service providers, and we have priority access to those when needed for an emergency. Probably be looking more in line of having that available from a service provider as opposed to owning it.
Thank you. Take one more question.
Good morning. My name is Steve Costin. I'm with PC Test Engineering Lab. We're located up in Columbia, Maryland. My colleague Phil Inglis and I were talking earlier at the break about certainly the criticalness, obviously, of the interoperability and the implementations specifically within the UEs and things like this. One of the areas that obviously is very critical is the accessibility access to these particular areas. And I wanted just to punch down a question back to the panel to just ask if, for consideration of network, certainly interoperability and handling, as well as device implementation, would you have any thoughts on defining these requirements, how they may be conveyed from a standpoint of compliance? And we talked about testing, and we talked about the value of validation, and if you would just be able to entertain that a little bit with a comment with respect to the public safety access. Thank you.
Anybody want to try to answer?
Yeah, a very broad question, so I'll do my best to answer the bits I understand and hand it off. But probably the easiest, I'll start with the easiest thing to resolve, I think, is the aspect of RF. I mean, it's well understood. It is RF, and it's fairly easy to go and measure and test for compliance. I think when we go up to layer 2 and 3, it gets a little bit trickier, and we've seen, and again, this aspect of interoperability is not something that we will attain and then relax about. It's something we will revisit every 6 to 12 months as we introduce new capabilities in this network and try and evolve the performance of the network. So interoperability isn't a one-stop activity. It's an ongoing. It's life as usual, looking forward. I think the aspect of moving up the stack a little bit further to the aspect of authentication, I see a tremendous opportunity to build a unified architecture for authenticating users. And authentication in an LTE domain with the IMS core is very complex and multivariable. It's rather like getting a large Lego box for Christmas and discovering there are 22,000 pieces. And that's what authentication and the IMS core more broadly looks like today. So the implementation guides that were mentioned in the previous panel are very, very key, specifically around authentication, to ensure that frontline responders and emergency responders can get access to the network and the services and applications that the people who govern these networks want them to have access to, right? And that's really key, and that's a function of SIM card, it's a function of SIM card directory, of the authentication protocols themselves, and importantly, the centralized network, which would be the home subscriber database, which will have to be unified if in national interoperability is to be achieved. So I don't know if I did answer your question.
Well, and I will tie it back to the criticalness of when we refer to accessibility, we're talking about the accessible hearing aid compatibility or availability for the devices to be utilized by a deaf individual like we're captioning today. From a public safety standpoint, those are the critical things to be thinking and looking for as we go into the future and we begin this implementation process and this integration process with LTE going forward.
With respect to accessibility for frontline officers who are using hearing aid equipment, was that your question?
Yes.
Oh, okay. Well, I apologize. I answered the wrong question.
Well, in a general sense, of frontline officers, I specifically tried to drive it back to public safety, but it could be users in general, obviously, you know.
I'll try and answer your question correctly this time. I think the one opportunity that was mentioned by Alan is with LTE. There is an opportunity to relay, and that opportunity is not clear with previous generations of technology. I'll set the use of Wi-Fi aside for a moment, just talk about the relaying of LTE signal. Hearing aid compatibility is a function of radiated power and directionality of power, and that's in direct conflict with the economy of coverage. So more cell sites would lead to lower power levels, which would lead to higher degrees of hearing aid compatibility, but that's a tension on economy. But the opportunity to relay is new and something that we need to fully explore, and I think it has an application possibly in this area of improving hearing aid compatibility and also driving economy on the network side at the same time. I hope that answers your question.
Thank you, Mark.
Thank you, panelists. It's been a very excellent discussion, and I'm very grateful for you attending. I was just going to say before we break, do you want to say something before about time to return?
I'd like to thank my thanks as well, and just remind everyone we have an hour for break, but we have a full afternoon too, and it is Friday. So I'd request that everyone come back by 1 o'clock so we can start on time. And thank you. The afternoon session of the Interoperability Forum. We're going to start with some brief remarks by Amy Levine. Amy, for those of you who don't know her, is the special counsel to the chairman. So with that, Amy.
Hi, good afternoon, and thanks so much for being here today. My name is Amy Levine, and I am special counsel to FCC Chairman Julius Janikowski for public safety and spectrum issues. It's my pleasure to speak on behalf of Chairman Janikowski at today's forum on the technical framework for a nationwide interoperable public safety broadband network. Fulfilling the recommendation of the 9/11 Commission that we ensure communications connectivity between and among first responders by connecting and deploying this network is a top priority for the chairman and his fellow commissioners. The Commission voted unanimously in January to move forward with developing a framework for nationwide interoperability. Many questions remain unanswered and much work remains to be done, but the robust discussions taking place at today's forum are an encouraging sign that we are moving in the right direction. As the chairman remarked at the January meeting, the success of this network will depend on our development of a national interoperability framework. If we do not put in place an adequate technical structure for ensuring that the nationwide public safety broadband network is interoperable, we will not realize the full potential of broadband to revolutionize public safety communications and emergency response. An interoperable public safety broadband network will enable first responders to communicate more effectively with one another over multiple platforms and in real time. There are an astounding array of applications and services envisioned for the network. First responders at the scene of an accident could remotely access medical records and send critical information back to hospitals, while firefighters in the field could download maps and blueprints before entering a building. Such capabilities and countless others will make emergency response safer and more efficient, thereby saving lives. The transformative potential of a nationwide interoperable public safety broadband network makes it imperative that we have in place an effective framework for interoperability from day one. Accordingly, the Commission last April created the Emergency Response Interoperability Center, or ERIC, and charged ERIC with developing such a structure. ERIC has been greatly assisted in its efforts by the Technical Advisory Committee, a group of state and local government representatives who provide expert advice on the many technical issues ERIC must address. Going forward, ERIC will also enjoy the assistance of the Public Safety Advisory Committee, or PSAC, a federal advisory committee formed to provide recommendations to ERIC and to the Commission on a broad array of public safety policy matters. The group's leaders are Chair Jeff Johnson and Vice Chair Eddie Reyes, two distinguished public safety officials with vast experience and expertise. The PSAC will hold its first meeting on March 15th, less than 2 weeks from now, another encouraging sign that we are moving forward. I will close by emphasizing the importance of the Commission's interoperability proceeding and of the work that is being done here today. Almost 10 years have passed since the horrific acts of September 11th, 2001. In its final report on the events of that tragic day, the bipartisan 9/11 Commission concluded that inadequacy in public safety communications remain a serious problem for first responders at all levels of government. 7 years since release of that report, this problem remains unsolved, and nationwide interoperability remains elusive. The purpose of today's forum is to help us move closer to a solution. We have a unique opportunity to get things right from the outset by establishing a robust technical framework for the nationwide public safety broadband network. We cannot afford to waste this opportunity. On behalf of the chairman, I'd like to thank all of the participants here today for helping us ensure that our nation's first responders will finally have access to the state-of-the-art interoperable broadband communications network that they deserve and that our nation desperately needs.
With that, I'd like to introduce our moderator of our third panel, Dr. Henning Schultzring, whose name I'm sure I've now missaid, who's going to talk today with the panelists about core network security and services. So with that.
Thank you, Jennifer. Welcome to the afternoon session. In the morning, we already talked a fair amount about the importance of not just ensuring interoperability at the radio access layer and the equipment side, but also to ensure that applications work across domains, across users, and that the network that we build can be secured at reasonable cost and effort. So as part of this panel, we will be exploring, based on existing experiences that we can draw lessons from outside of the public safety broadband area, as well as more general considerations, how to accomplish interoperability, as one might say technically, up and down the protocol stack, not just at the lower levels, physical and radio layers, but also all the way up to the application protocols that we need and the middleware that goes along with that. I've been delighted to work with a distinguished and experienced panel that has had the benefit of actually dealing with many of these issues on a day-by-day basis. So for this panel, we have Walter Magnuson, who's the Director of Telecommunication at Texas A&M University, and relevant here, also Director of the Internet 2 Technology Evaluation Center. We have Byron Neal, who's the Chief Network Architect at Cineverse Technology. And then John Powell, the Interoperability Chair of the National Public Safety Telecommunication Council, also known as NIPSTIC. And finally, Jack Seuss, who's the Vice President of Information Technology and Chief Information Officer at the University of Maryland, Baltimore County. But again, here speaking probably primarily in his role as the chair of the In Common Steering Committee, and he will be explaining what In Common is in much more detail than I want to do right now. With that, Walt, why don't you get started?
Thank you, and as others have indicated this morning, I would like to extend my thanks to the FCC for inviting us here to present on this project and this process. It's very important to all of us. So if you could bring my slides forward, I'd appreciate it. Okay. To give you a little bit more background and kind of where I'm coming from on this, I've been involved in the public safety sector part of this work since 2004, where we worked with the Department of Commerce at first and later the Department of Transportation to work on rollouts and deployments of the Next Generation 911 initiative. We were honored to be able to do that with Columbia University, so we've been working in that space for quite a while. And that's from my research role. My administrative role, currently one of the services that we manage on campus is the P25 radio network, and there we work with our 100 and some police officers on campus who have a relationship with the local community as well, and working with the greater Harris County network. So we've been working with building emergency communications networks and radio networks for quite a while. More recently here, I also have acquired a role as the public safety community advocate for the U.S. UCAN project, which I'll talk a little bit more about later on in this presentation. Public safety requirements, and again, I'm kind of reiterating what's already been said, but there's requirement for local autonomy. If you look at it, basically, it's the local communities that build the local networks. That's not going to be done in a national network. But there is a requirement for national and regional roaming. Obviously, there's a high requirement for collaboration. That's very, very key to what we do. Now, if you're going to do this, what kind of support do you have to have behind it? Obviously, you need infrastructure, towers, co-location space, backhaul, and then, of course, standards. The infrastructure part of it, you know, that's the unfortunate part. We've talked a lot today about the capital expense, the CapEx. The reality is, it seems like what really kind of gets us every time in the end here is the OpEx, and that's where the towers, the colo space, and the backhaul really end up being the significant impediment to getting any of this done. So going forward, again, there's been a lot of talk today about LTE and talking amongst LTE networks and talking between LTE networks, but the other reality is that LTE is not going to be the only thing in the world that it needs to be able to talk to. While most people, or a lot of people, have mobile access, the reality is there's a lot of the world that's on hardwired communications and landline communications as well. So if you look at it, it was also said earlier today in the last panel, you've got the P25 networks out there handling voice. They're not going away anytime soon. You've got both public and private LTE networks. But in addition, there's this box there on the bottom, which is really key. That blue cloud in the bottom slide, that indicates the ESI networks, or the Emergency Services IP networks. That is the infrastructure that is being designed as part of the next generation NG911 network. And the difference between existing NG911 networks and between existing 911 networks and NextGen is that NextGen not only is IP-based, supports a lot more services than just voice, but it also really will be connected to all of the first responders, not just the initial call takers. It's really important as we go forward with this that while we have interoperability between the LTE systems and the mobile folks that are out there, that the interoperability also be managed and dealt with to the ESI net, in that a lot of the people that are going to be calling in, a lot of the people that will be providing information are not going to be on the LTE network. They'll be on the legacy internet, they'll be on other networks out there. So that part of it's really key to what we're doing. Okay, why is this such an issue? Because again, while we have all talked about the fact that the radios themselves are very expensive, etc., the operational expenses, I think, basically are really being kind of underestimated as we go forward with this. Currently, we've got a P25 network. P25 network, when you're going to a tower, and our current system supports 2 counties. With the 2 counties, we've got 7 towers. Each tower has a T1 connected to it. So you're running at about 1.5 megabits per second. And each one of those links operationally is, you know, couple, $200-300 a month for T1. Start looking at LTE, you're not talking about T1s anymore. You're dealing anywhere from about 100 to a 200 meg link to every one of those towers, which realistically means you're either dealing with microwave backhaul or fiber backhaul. And again, as was also indicated earlier today, the rural part of it is very important, and in many of the rural areas, broadband access is limited. So whereas the current LTE network, just for our operational network in Brazos and Washington County, Texas, is right now running us about $118,000 per month, I'm sorry, per year, excuse me. We're looking at the LTE network running about $500,000 a year, and the reality is it's not a trade-out because we're not going to shut down the P25 network when we turn up the LTE network. The other issue is that currently in emergency communications, there's really nothing above the state level in terms of an authority. I mean, in essence, or management and funding. For the most part, most of the funding is local and at state. There's really no one out there right now that is running a national backbone that's designed to run all of public safety. And again, keep in mind that there will not just be one public safety network, but there will be two public safety networks, one for the LTE network and one for the ESI networks. And while a gentleman this morning talked an awful lot about the importance of sharing, I think in this case the sharing is mandatory because public safety is not going to want to run two side-by-side sets of infrastructure that are separate and costing them duplicate dollars. Okay, so what's the equivalence of this in higher education? You know, why am I here talking about this from a higher ed role, again, when this is really a public safety issue? Back in about 2006, or I'm sorry, back in 1996, higher ed looked at the same thing. They said, we need a special purpose network to meet the needs of higher education. We have things like video conferencing, we have distance education, we have requirements that provide access for high-end supercomputing, etc. And in essence, with public safety, it seems now that there's kind of two models that may evolve. Federal government may come in and fund the whole thing, in which case it's all taken care of, or it will be a bottom-up type funding initiative. In higher ed, it pretty much had to be a bottoms-up type initiative. So the model that evolved there was just like in public safety. In higher ed, everything is local. The universities, in essence, is where a lot of our focus is. But since there was a requirement to build these collaborative networks, we created regional optical networks. Some of the regional optical networks are multi-state in nature. For example, the Merit Network in the Midwest covers many states. The Texas Learn Network and the California Scenic Network and the Florida Lambda Rail each cover one specific state. But the bottom line is, universities, both private and public, got together and created these regional networks. Then the regional networks were all interconnected to create a national network, which is the Internet 2 network, which currently is a multiple 10 gig backbone that covers the entire U.S. plus has peering internationally. So in essence, I think we've shown that a bottoms-up approach will work, a bottoms-up approach can work, providing everybody that needs to be involved can get together and work together on this as a team. So how does Internet 2 work? Both funding and governance. Funding, in essence, all of the universities pay into the regional networks. All the universities also pay into the Internet 2 network. So, and then the regional networks then funding to help support some of the national funding initiatives as well. And then Internet 2 deals with the funding between the individual countries or the international peering sites. Governance is the same thing. Each university is a voting member. Each university that is a voting member then goes ahead and also elects a board of directors or an executive board, and the executive board helps set the guidelines, rules, and everything else. Most of what we're doing is not run, and most of the stuff we're doing is not built on private fiber that is built in university networks. Most of the stuff we're doing, for example, Internet 2, is running on top of carriers' infrastructures, inside of carriers' co-location services, but it is a special purpose network that's designed to support the needs of higher ed. Again, what we're talking about here is a special purpose network that would support the needs of public safety. In process of upgrading the Internet 2 backbone here last year, Internet 2 went forward to the NTIA and received about $96 million, or was working on a $96 million grant. The whole project is $96 million, about 2/3 of that is funded by the federal government, which is the US UCAN, or the United States Unified Community Anchor Network. And US UCAN is designed to be a nationwide 100 gig backbone, and that nationwide 100 gig backbone is designed to also support anchor tenants. The NTIA was very adamant about the fact that they wanted anchor tenants to be the backbone of the network once it was built. We very clearly specified that public safety would be one of our anchor tenants. So again, what we're doing now is reaching out to the NTIA and other people who have currently the NTIA grants to do the LTE radios as well, to see how we can partner and again use this new resource that was provided through federal funding to make sure that we can support public safety to the best of our abilities. Okay. And basically, that's pretty much it. There is one more slide. I think in essence, most of the stuff again that I'm talking about here has already been pretty well discussed earlier today. So let me go ahead and then cede the table to Byron here, and let me go ahead and pick up anything else that's asked later in questions.
All right, thank you very much. My name is BJ Neal with Cineverse Technologies. I want to talk to you guys a little bit. First of all, I want to thank the Commission for the opportunity and the public safety community for the opportunity for us to be able to participate in such an important mission for our country. So thanks a lot for that, and very happy to be here. I wanted to talk to you guys a little bit about the packet cores and how they're interconnected today, and how what the security aspects of the roaming exchanges are today. So today, packet core networks, mobile packet core networks, are interconnected from a roaming perspective through what are called roaming exchanges. I don't have any slides. Today, for the CDMA operators, that network is called the CDMA roaming exchange, or commonly referred to as a CRX network. For the GSMA operators, that's generally called a GPRS roaming exchange, which is also known as the GRX network. And for LTE, the GSMA has specified that the network of choice between the LTE packet cores will be what's called the IPX network, which stands for Internet Packet Exchange. The IPX network was developed by the GSMA Association to actually be the successor to the GRX network. It turns out that LTE sort of, from a standards perspective, does a pretty good job of following in the footsteps of the earlier GSMA family rather than the CDG family. So the CRX networks were specified by the CDVA development group. GRX was specified by 3GPP and adopted by the GSMA, and IPX similarly has done the very same thing. Now, there are some differences in how authentication and authorization aspects occur in these different types of networks. For CDMA roaming exchange, the authentication and authorization is sort of handled through a radius protocol that's a little bit different from GRX, where that authentication is done through the legacy SS7 networks through a protocol called GSM map. So as we move into LTE, we've got a new protocol to deal with for authentication and administration for signaling between for subscribers who are visiting roaming networks. And Diameter is the protocol that's kind of a successor to Radius that is being used in the IPX network. Now, the reason I bring this up is because these networks have been in place for many years. Many different companies have been able to solve interoperability problems between many different types of mobile network operators and mobile network standards for quite a while. I want to touch a little bit on the security aspects of that, because I want to point out that all of these networks, both the legacy CRX and GRX, as well as the IPX, are managed, secure networks that are inaccessible by the public internet. So all of the network elements that are in play between mobile packet cores from a roaming perspective, those network elements are not publicly addressable by the internet. You can't ping those from the internet, which inherently makes them much more secure than network elements that are exposed to the public internet. The reliability factors are huge as well. A lot of these roaming exchange networks have been evolved from earlier SS7 networks. There's a great deal of reliability and redundancy involved in these networks, because that's the way SS7 networks have been built from the beginning, because they were absolutely critical to making sure that a phone call could be made from point A to point B. So not only are these roaming exchange networks very secure, but they're also highly reliable. And from that perspective, we feel like those will meet a lot of the needs of public safety very well. Another aspect of this between these roaming networks, another security aspect of this is as a subscriber goes into a visited network. So if a public safety entity goes into a visited public safety network and he needs to access some content back at the home network, there's actually a tunnel that's established between the serving gateway and the home P gateway that's actually encapsulated in a tunnel. And there's different types of standards depending on the way the network is built, GPRS tunneling protocol or mobile IP. Again, the point is there's a fair amount of security that's inherent in the tunneling protocols between the visited and the home network that make it also very conducive to public safety needs. So in other words, you would need physical access to these network elements, which is not really possible unless you're authorized to do so. And you would need some fairly sophisticated deep packet inspection equipment to be able to decode some of those packets. So, we believe that will serve public safety needs very well. So there's some other aspects of IPX that were not originally designed into the predecessors of CRX and GRX, which is the concept of a class and quality of service. The CRX and GRX networks were designed as a best effort network service. So when mobile operators originally started providing data services, they felt like best effort was good enough at that time. Obviously, as we know, we are relying more and more and more on our mobile devices and mobility in general. And best effort quality of service is not good enough, especially for first responders and for the public safety sector and other new applications, machine to machine and other things coming forward as we go forward. So GSMA realized this and specified that class and quality of service would be very important within these IPX networks so that we could put many different applications over the same network infrastructure, and we could logically separate that both from a security standpoint and a functionality standpoint. So the IPX networking functionality between the packet cores are very much an application agnostic design that were specifically designed and built so that any application could traverse this network regardless of what its function or mission was. So again, we think this is very helpful and useful for public safety purposes. The reason that I sort of presented this in this way is because I read a little bit of the material before the meeting where the commission asked us how much bleeding edge technology is some of this. How bleeding edge are some of the things that we are doing to provide for public safety. I can't speak to the radio interface very well because that's not my area of expertise, but I know around the room there are lots of guys in here that can tell you all kinds of things about what the radio networks are doing to provide for security there and what the level of technology is there. But in the exchange networks between the packet cores and that's even true for CRX, GRX, or IPX, I wouldn't say that this is very bleeding edge technology at all. These are pretty standard networking protocols that are used today in a lot of networks and have been for many, many years. And in fact, we're going out of our way to make sure that we don't invent too many things because, again, reliability is very key to making sure that this network is interoperable. So from that standpoint, I think it's good news, and I want to allay some concern, I think, on behalf of the Commission that, from the standpoint of connecting these mobile networks together through the roaming exchanges, it's in my view, not a high-risk item from a bleeding-edge technology perspective. So that's all I have for now, and be happy to participate in going forward. Thank you.
And we'll see if we can get a slide up here. Where do we point or is this RF?
There you go.
There we go. Good morning, everyone, or afternoon, I guess. Where I'm from, it is still morning. My name is John Powell, and I'm here representing the National Public Safety Telecommunications Council, which is a federation of organizations whose mission is to improve public safety communications and interoperability through collaborative leadership. It includes all of the major leadership organizations in the country: police chiefs, fire chiefs, EMS officials, sheriffs, and a number of members from our what some people consider second responders, highways and so on, but I always like to point out to people that depending upon the incident, they may be the first responders. If you're in the Northeast in an ice storm, until the highways are open, nobody goes anywhere. So it's very incident-based as to who first and second responders are. I come today, I've got about 32 years of law enforcement experience from the San Francisco area at state and local level. It was interesting to hear Walter's comments because 30 of those years were at the University of California, and I watched with interest as Internet 2 was spawned at the turn of the century. And Byron, your comments on bleeding edge, I always like to remind people that when we talk public safety, bleeding edge involves real blood. And our first responders in the field do not like to be the ones testing new technology. They want it to be sure that it is working right and has been well tested before they get it. I thought coming third, I would probably be have people already talked about the broad picture of security, but I guess my slides, if you look at them, just to give folks a general idea of what we're talking about in the broad picture of security, many aspects. Accounting and audit, I put an asterisk after audit. Some people question whether that's part of security, but certainly on the law enforcement side, audit is a huge part of security. Authentication and identification, integrity of content, all kinds of network and end user threats from DOS, denial of service, intentional and unintentional human threats, playback spoofing, viruses getting introduced to the networks as we've seen happen with some of our handset technologies more recently. Non-repudiation. Non-repudiation means that someone can't deny that they sent something, or at least that their device, their handset sent it at some point later, no matter how much they might like to do that, depending upon what happened after, during, or after an incident. Privilege management involved in setting up user profiles, and validation. And those are just some of them. Not, in many cases, easy to address. And it continues from there. While information being sent to end subscriber devices may actually cross thousands of miles in a roaming or travel situation where someone from my agency on the West Coast may be back here in Washington, the link that we're really looking at for the public safety broadband wireless network is that last mile. And we need to keep in mind when we're talking that last mile is supported by incredible amounts of wire-based in the broad term. You know, some connectivity other than wireless. Network requirements for security exist at many levels. We have, of course, core and RAN, the physical security of those facilities, making sure that someone can't get in and mess with the equipment inside, take them off the air by cutting fiber or something, power coming into them. Physical security, as I said, of the network links, whether they are commercial or government owned. Network security at various levels within the OSI model. I'll talk about a couple of those in a little bit here. Physical security of the subscriber device itself. And very often what we're looking at in some of these is simply protecting the time-critical nature of delivery. It doesn't matter if somebody hears an instruction in a SWAT operation, the shoot, don't shoot instruction that might go out over a PDA type device. What's important is that be delivered instantly to the person on the end and not a half hour later. So time criticalness for some of our mission critical applications is incredibly important. One of the things I've been doing, and I left working for the University of California back in 2002 and began supporting the Department of Homeland Security as it was standing up as a contract support. But in about 2004, I got involved with the Department of Justice Global Security Working Group, or GISWIG, particularly working on the wireless components there. And in that organization, we address a lot of statutory requirements. And just because we're going over a national network, that last mile still has to meet those statutory requirements that exist. It may be for criminal justice information systems, such as the FBI's NCIC 2000. Virtually all of the states and many local governments also have their own statutory requirements that people operating within those states also are required to comply with. We have on the EMS side the HIPAA requirements that certainly are getting more and more important to as medical data is spooled to the field, and that's going to be going over this last mile network. Interestingly, if we bring, and all of us in the user community see it being only natural that we bring our federal partners onto this network, understanding that there are some legal hurdles that we have to get over for that to happen. They bring some special requirements for their internal and Fed agency to Fed agency communications set up through the Federal Information Processing Standards, the FIPS publications. In particular, their Type 1 encryption requirements. And as an example there, if for some reason they have to translate that information, say they're going from one encryption standard to another, they can only bring that back to plain text inside of a secure facility. So the physical secure facility where that translation is happening has to be a Type 1 certified facility. Everyone inside has to have clearances, et cetera. It is not an easy issue. Therefore, for us, end-to-end encryption is a really important concept wherever we can get that. I mentioned CJIS and CORI, Criminal-Oriented Record Information. Those are particularly onerous to deal with because of some of the statutory requirements with regard to sharing, such that some states will only allow particular fields within their CORI information to be shared. This is criminal history information. With other agencies, even their neighbors. They will say, we can share a name and a date of birth, but I can't share by statute. My city has passed an ordinance that says I cannot share a physical description of that individual. I can share a name and a date of birth, but I can't share a physical description. I can only share these pieces of the criminal record. The audit. Oh, and by the way, audit is an absolute requirement there. Who got it and what they did with it. And if that goes across this part of the network, it is a part of that process. That all has to be maintained, and they will come back and do physical audits to make sure that they knew what happened to that information. We have spent huge amounts of time within the GISWIG addressing just that particular audit issue. And I mentioned that on this slide. Following standards-based requirements, the last mile requirement, following our wired requirements, and using practices such as those established by the Global Federated Identity and Privilege Management Framework, GFIPM framework. That is what most of the states are following today for exchange of their criminal justice and CORI information. That is something we need to be very aware of on the wireless side, because everyone that is using commercial wireless today is following those standards. They're typically doing it with a VPN type of application. Fortunately for us, on the network side, LTE's inherent 256-bit AES encryption meets the GFIPM requirements for security at the lower levels of the model. At the higher levels within the OSI model, we're going to have to look at the challenges that are going to be presented in ensuring that we have applications that are interoperable, especially the major applications. I know the Commission has already addressed this for some small number, but there are going to be a very large number, and they're going to be, as was mentioned in an earlier panel here today, they are going to be very specific to the end user and the service that the end user is representing, fire, law enforcement, highways, whatever that might be. And I think we're going to find, particularly in the medical field, they're looking, and knowing several of the people that are looking way forward in what they may be doing, they're looking at some really important things that this network could provide, for example, in a rural area to a small clinic that might have one doctor and a few nurses, and they have a bus or an Amtrak accident, and the closest backup is hundreds of miles away. How can they make use of this network for remote diagnosis and assistance with the other less trained professionals? But it's all that we've got here, and we're in Tonopah, Nevada, as my good friend Dick Murgon mentioned earlier today, and we've got this huge crash, and how can we provide some treatment better than we can today using the facilities and this network to deliver that? It's possible, but the applications to do that are going to have to be standardized. Last and certainly not least is roaming to commercial networks. Today we do that, and as it was mentioned here also in an earlier panel, it is done extensively for providing these kinds of services over one of the major commercial networks today. It is normally done using a VPN. State of California, for example, that's the only way that you can do it, and they give you a lot of the specifications that you have to use to do that with any information that originates out of the state. And with the federal model, everything from, for example, NCIC comes through the state. So if it is going to a local agency in California, whether it's county or local, it's going to follow those state requirements. It's going to go over a VPN. Are they doing it? Absolutely. It's working great today. I will tell you that the dispatcher loves the auto investigator who's crawling around under wrecked cars at a wrecking yard checking VIN numbers to be able to do that off of his PDA without being on the voice radio system, asking them to run license plate or VIN number after VIN number after VIN number. And the guys in the field love it because they immediately get back all of that information. And by the way, if they happen to be using a driver's license, they get back the picture that's on the driver's license. So if you're out on the beach and John Doe says, "I'm sorry, I left my driver's license," they now get a picture and they can verify who that is. In closing, while we're focusing today on network security, I want to also remind people that we have a need for off-network communications. We want to make really sure in the process of doing our on-network security considerations that we don't do something that is going to make it more difficult to do the off-network security, because it's going to be difficult enough to do that. I want to make one last and my contact information is up there now for anybody that wants to write that down. One last comment. One of the very first things that I had the opportunity to do when I went to work for DHS shortly after 9/11 was to author a document probably everybody in this room has seen called the SafeCom Continuum. I was the principal author of that. Lots of help from a number of other people in putting that together. There is a reason that the lanes are structured on that the way they are. It's not, they happen to be alphabetical. That isn't the real reason they're that way. They're that way because of two reasons. Number one, the difficulty in addressing those various 5 issues, starting with governance being the most difficult. They're also there because it's the order in which you need to address the problem if you're building a network. You always start with governance first. When you have your governance model put together, you then move to your standard operating procedures. How are we going to use this network? And then you pick the technology that meets the needs. That doesn't mean you can't address the technology simultaneously. You can't address some of them simultaneously. After you get the technology platform in place, you train people, and then you begin using it. We need to address governance while we're looking at technology. That is a critically important issue. And that governance has to happen among the users of the network. It cannot be driven top down. We know that doesn't work. History tells us that. Thank you. Thank you.
Which one do you press? Oh.
There you are.
Okay, thank you. Well, I'm going to speak a little bit above the network in terms of thinking about how we might launch services. And I want to start by just sort of highlighting 2 points that the other panelists, I think, highlighted. One was Walt's comment about the breadth of relationship local, state, and national. This is going to have thousands of entities that are needing to work together, and I think that creates some very interesting issues. I think the other challenge that we have to face as we think about this network is that while we must have interoperability, we also need to be able to support innovation. And so thinking about how you can allow different groups to do different things are going to be key. I'm going to talk a little bit about In Common, which is our higher ed federation, but I just want to use that as a model and talk about how that may be applied or applicable to this effort that's here. One of the key issues that we have as we begin to think about federation is that federation brings a group of members together that have a relationship built on trust in some form or fashion. Usually it's instantiated at some way through an MOU or a contract, and then they agree to a common set of practices. It's sort of back to John's point about governance that we had there. In Common is an example of what higher education has done in terms of launching a federation. Today we have 200 universities, 71 commercial partners, and 8 government agencies or labs that are interoperating together, sharing applications, sharing identity and services in a way that I think could be a model as we look at some of the next generation applications. All parties sign a contract within Common. We agree to a set of common attributes that we're going to be prepared to interchange. And by defining this small set of attributes as to how we're going to be working on problem space, what we're able to do is mask some of the complexity that each of us has in our different back-end systems. You're responsible for just populating a small portion of the kinds of information that you're already recording from your massive ERP systems. Let me go to the next slide. The way we do this is we leverage some standards. SAML is an international standard. We also have open source tools that we've developed. We put them into the public domain. There are commercial vendors who have implemented their own tools that can work in this environment, and I listed some below. Our goal is to make sure that this is something that can be used not just in the United States. There's also 21 countries have established national federations and are using similar technology to interchange information amongst universities and other entities in their country. Next slide. The present way that we often do things is we've got services. We may be associated with a particular district or county, but then we may be accessing services that are at DHS. We may have state services that we need to connect to. We may have medical services that we need to connect to. Often these services rely upon people having multiple accounts and passwords to be able to access those services. That becomes a tremendous challenge in trying to think about how you provision services, especially when you have first responders coming in from outside of a district into a new environment. How do you begin to get the information that's needed to handle these large-scale emergencies quickly? Go to the next one. So using federation, what we leverage is the fact that you probably have a relationship with your local district in terms of how you would authenticate yourself. You have an account, you have a password, you have a security mechanism that's been agreed upon. What you're able to do is leverage that local authentication to access remote services. When you go and access a federated service, what happens is it will ask you to identify where your identity provider is. You are then redirected to that identity provider. You perform an authentication mechanism, maybe using whatever authentication tools you're using with that local identity provider that you have. It might be a certificate, it might be a hard token, it might be a password. Whatever you decide to use, you're then, once you've authenticated, you're redirected back to the service provider. Attributes are passed and your access controls are set up in order to give you the level of information that you should be able to get. One of the interesting examples of this is back in 2005, we set up a example after Katrina where a number of the hospitals were needing to interchange information about evacuees. We were able in 72 hours to interface multiple hospital systems and be able to have an evacuee tracking system that worked across multiple states and multiple hospital systems up and running in a very lightweight fashion. These are the kinds of things that you need to be able to do in large-scale emergencies. One of the key roles of federation is really, and I think it speaks to John's point about governance, but it's a definition of metadata. What are you going to be using as attributes? What are the core elements that you need to be able to track? What are some common practices that are going to be expected among the participants that are part of this federation? The federation often functions as a digital notary, so to speak, and it is making sure that everyone is agreeing to abide by the basic rules that are there. It handles the contract negotiations between each entity and the federation, and it oversees this trusted exchange of metadata that happens on a regular basis, so that as you are deciding that you want to provision services to new groups, this can be done on a very flexible basis and in a very short time frame. Go to the next one. So this sort of example that sits there is an end user at some home district will decide that they need to access a service. They go out. They are trying to get a service from some party that is not part of that home district. Again, they'll select who their identity provider is. The identity provider is then given information as to what service they're requesting, along with what attributes are being requested. The identity provider can determine whether it should release that information. Is that something that we're willing to release to this service provider? And it's something that, if they are, they would respond to this and move forward. One of the interesting things that higher education has done, which is really quite interesting, is that we also build in privacy controls. We can do minimal release of information. So we may not necessarily release the fact that it's John that's accessing something, but we can also release John is a policeman of a certain level, and that might then give access to specific kinds of resources that we've geared to police or medical or others. And that can enable the access control mechanism without having to get down to fine-grained authentication that would be there. Lastly, I think that one of the things that we focused on in looking at federation is that you're going to have very different needs for security. There are going to be some items that, and I think John spoke to some of this, there are some items that you're going to want to grant access to based on a person's role. There may be others, though, that because of HIPAA or other kinds of sensitivities need to be protected in a much higher grained way. What we've done with federation is the service provider for a particular resource determines what level of access is needed in terms of assurance. It can instruct that back to the identity provider. So it may be that for certain resources, I need to have not just a password, but also a certificate, or I need to have a hard token to be able to access this. The good side of what we're thinking about in this model is it's very flexible from a technology standpoint. It can adapt, and as we think about the kind of changing landscape that I think we'll be seeing in terms of devices over the next few years, this is going to offer a lot of flexibility for some areas that want to innovate and be somewhat on the leading edge in terms of deploying next generation devices to their first responders, but it'll also support other entities that may be looking at being a little bit trailing edge. Maybe it's a smaller area that is not prepared to invest in new technology. They want to see it proven before they move in that direction. This model of linking services through federation can be a great way of trying to support the adoption of innovation in a time scale that works best for the wide variety of entities that are going to be there. And that was my last slide.
Thank you, everybody. I want to move ahead with just a few questions that I might help dive into a little bit more detail on the individual presentation. starting with Walt, I wonder if you could tell us just, I find it helpful to get some rough numbers or orders of magnitudes. How many users would you say, roughly speaking, would be using Internet 2 on a daily basis? Would you say tens of thousands, hundreds of thousands? What's your best estimate, just to compare it to the challenge you might face in a public safety network?
Wow, that's a hard question. There's about 209 major universities that are tied in Internet 2, but they also, through the SEGP, which is a sponsored affiliations, support community colleges and K-12 as well. So you've got a large number of members that fall into that role as well. Plus there's high-speed peering with the GEONT network in Europe, the APAN network in Asia. So I would venture a guess that it's well in the millions.
And roughly speaking, just to, again, just put some numbers on this, when a campus or a small institution, like a community college, wants to connect to Internet 2, you hinted at that was a monthly fee relationship. Can you just, again, since most of us won't be knowing about, roughly how much are we talking about?
Again, it changes from state to state, but with the smaller the institution, K-12, for example, typically is outside of the link itself is typically in the hundreds of dollars per year. Medium-sized institutions is in thousands of dollars per year. And when you get into large institutions like the Tier 1 research universities, it can be up there quite a ways. But it ranges quite a bit. It varies quite a bit with the size of who's connecting.
Okay, thank you. BJ, I wanted to follow up a little bit on, you spoke a lot about the IPX network, and I was curious as to, and you mentioned diameter as the authentication mechanism. I was curious as to the two roles that it might play. Namely, one is as a network to exchange authentication and authorization information, and secondly, the actual peering, if you like, exchange of voice or data traffic in that. And if you could illuminate a little bit what role it plays on both of those aspects.
Right, certainly. So the IPX was designed and is built to handle both the signaling plane as well as the user plane. So on the tunneling protocol between the visited and the home network, for example, the protocols at play are called GTPC, which is GTP control plane, and GTPU, which is the user plane. The user plane is generally considered what we like to call the bearer traffic. So if that's voice, those are RTP packets, or video, they may be RTP. They could be any number of protocols that are actually the bearer services between peer-to-peer or a user and an application. The control plane has a lot of authentication messages, start and stop, when sessions started, when they stopped. The IPX is designed to carry both, and there will be different class and quality of service configurations and attributes assigned depending on how tolerant one of those protocols is to packet loss, latency, and jitter, and some of those types of key performance indicators. But in general, that the IPX is designed and was envisioned by the GSMA to handle both the signaling plane and the user plane.
And so how far does this network as a physical network reach, so to say? Does it, is it a network where you would have to go to certain interconnect points in the world, or how does it physically work?
It's you can think of an IPX provider having a number of POP locations or points of presence locations regionally connected throughout North America, for example. Generally, a mobile network operator also has regional gateway connection points, if you like, between their mobile packet cores and external network entities. So I would envision that a mobile network operator would sort of interconnect on a regional basis throughout, say, North America, for example. And many IPX networks, including Cineverse, is quite a global network. We have POPs in APAC and Europe as well, and would expect to facilitate roaming and interoperability between on a glable basis.
And what do you have to be to connect to the network? I assume if I walk up and call them up and say, "Hi, I'm Columbia. I'm representing Columbia University," that would probably not take my check.
Fair enough. That's a very interesting question, because in the past, the CRX networks and the GRX networks, which are the 2G, 3G, they were specifically designed and around mobile network operators only. And so you definitely had to be a CDG member or a GSMA member to sort of get in the club, if you like. However, the GSMA specified IPX to bring a lot more than just the mobile network operator community in. So application service providers, content delivery providers, MSOs, wireline operators also are invited to participate in the IPX network. You know, that's a good question. I'm not sure if it would require that you need to be a GSMA member. That's a good question. If I may, I'd like to get back to you on that one.
Be interesting. Okay, thank you. And then I wanted to follow up with John a little bit. You mentioned a lot about the applications that you have. Now, you could argue that security awareness, fortunately, has spread a bit beyond just the classical kind of three-letter agencies. And so you have the question also, I think there has been a general philosophy of, as much as possible, reusing commercial technology for the public safety applications because of volume and just simply testing. You don't want to be the first user for any new application and do that in public safety. So I was curious, if you look at modern applications such as secured web browsers, HTTPS, secured email, IMAP-S, secure POP over SSL, and other secure RTP and so on, what would you see as specific challenges that we would have to address beyond operational concern? I mean, thou shalt use HTTPS for when you access a database, as opposed to new technology or new infrastructure or other things that are public safety specific?
Well, first of all, web browsers and the incredible power that you know, just internet research can bring, whether it's from pulling up building plans that are public documents, all kinds of uses like that. So that, I mean, that would certainly be the kind of application, and the built-in HTTPS security there, I think is going to be fine for most of these applications, because you know, the pieces of that can be fine-tuned, and generally I don't know that there would be much concern over people knowing what someone actually is even looking at if you're looking at a particular incident. Some of the big broadband wide requirements are not actually for incident management, they're for incident support. For example, you take in the West, which we have many of every year, a large wildfire. The capacity users are the people that are pulling down the maps and the weather data that are doing the predictions on where the fire is going to go. It's not the command team, other than maybe some video shots and things like that coming back and forth, which are time critical. And so their profile is going to have to make sure that those get through quickly versus you know, if it takes a little while longer for the mapping to come down, even though it's requiring a huge bandwidth, not so time critical. So you have some of those issues out there. But I think as we look widely at the kinds of applications we use, you could go to the services today and see what they're looking at. You know, the criminal, on the law enforcement side, the criminal records inquiries, the driver's licenses, the things like that. And as I said, now, when you do a driver's license inquiry, the fact that you're getting a picture back with it. Same way on a criminal records inquiry, you're getting a picture back. If that individual has scars, marks, and tattoos, you're going to get probably pictures back of those. So not big, but again, time critical. If you've got someone stopped out on the side of a highway, they're not going to want to wait an hour for that information to come back. On the fire side, a lot of what they're doing for reporting is after-action reports that get uploaded to databases that are then, you know, analyzed after the fact at the incident, pulling down building plans, pulling down information on potential hazardous materials and that kind of thing. And as I mentioned, the medical field, that I think is where we're going to see this need explode for real-time access and real-time sending of information back and forth for patient diagnosis and those kinds of things that are potentially going to be some big bandwidth users. 12 lead EKG, not necessarily a big bandwidth user, but the fact that it gets there 30 minutes after it actually was taken is of no good to anybody. So And when you're looking at video, making sure that the packets are delivered, and we look at some of this thing like NG 911, and all this information coming in from the field. Well, you got to remember somebody on the other end has got to be able to have time to look at that. So somewhere that information needs to be triaged, and you only push out what you really need to the people in the field. And if it happens to be a SWAT team going in on an active shooter, the picture that kid took and sent you from a cell phone is a critical piece of information. So, but somebody's got to look at that, because the responder in the field doesn't have time to do that except for the really critical pieces of information. So it's going to be a great potential, but we have to keep in mind that there's some realities involved too.
Okay. Jack, I want to give some time for questions for your answers as well, obviously, but two quick questions. Namely, one is, do you know of any attempt to connect the in-common type of infrastructure, SAML infrastructure, with the federal PIV type of cards, the smart card, that I guess now more or less mandatory for federal agencies and many state agencies? And have you heard any attempts there? You mentioned the GSA interactions.
So, related to smart cards, we do have an activity underway to be creating what's called a gold standard of assurance, which would have a smart card mechanism, and there would be no reason why you wouldn't be able to use the certificate that's on the HSPD 12 card that would be there.
One, if you could just give an example or two, just to make it a bit more concrete, of the kind of applications so far that have been in-common enabled, if you like, and the ones which maybe the ones which are most commonly used today.
So the most commonly used applications are really quite simple. They're students, faculty, and staff accessing library materials. Many of the library databases are central to the organizations that control them. And so what happens is as a person goes to connect to a resource, they're going out on the internet, and then they're being redirected and asked whether or not they have authentication. Some of the other kinds, though, as I said, we have 71 vendors. So besides library vendors, we have instructional vendors, we have administrative services vendors, we have Microsoft is a key partner in much of what we're trying to do. And so some of the Microsoft services are now accessible through Federation as well.
There are also collaboration applications, is that right?
Yes.
Yeah, so that's an important for public safety. Okay, and with that, I want to give the opportunity to the audience if they would like to ask any questions. Oh, sorry.
Well, I just wanted to make a follow-up comment on the smart card statement. One of the biggest impediments we have to rapidly delivering service today is people getting to the scene of an incident. We don't know what their capabilities are. So our hope out of this would be that a smart card, the one card type idea, is that we would know, we would have some trusted identification method as responders, and this could actually be volunteers too. Get to the scene of an incident, we know what their capabilities are, what they're trained to do. For example, if they have certain medical restrictions, what are those, so that we don't put people in danger and we make the most possible use out of them that we can. Incredible issue that came out of the follow-up on Katrina was that we had people out there who were qualified to do many things, and they were put checking people in at a rescue center instead, and they're trained medical technicians, and they're not just being used right because nobody could trust the information they brought with them.
Okay. There's a question there from the audience.
Yeah, Mark Adams from Northrop Grumman. John, I want to ask you a question specifically. You seem to have thought through the security issues quite thoroughly. When we deal with DoD or other customers in the federal arena, it's very clear to us who the certifying authority is for operation of a device on any different type of network. And we have to get certification approval for operation. To date, I am not clear how this network is going to work in that fashion. If we leave it up to each jurisdiction to worry about, which is I think kind of where it exists today, to worry about the certifying authority for operation on their network, it seems a little bit dangerous when you start talking about the fact that you mentioned HIPAA might be, HIPAA traffic may fly over this network. There may be other interoperable interoperable federal agencies, information from FBI sources, other justice information. So it seems to me that we really need to think through who is going to be the certifying authority for these networks to, I guess, create some kind of concept of authority to operate. Do you have any comments on it?
Sure. If you look at what Global has done through the GISWIG at the law enforcement side, I think it gives you a good model where they've got a federated ID system with trusted partners. In the end, I think in this network, it is going to go back to the individual agencies to put the information in and to take it out. Just as important when someone leaves to take it out or someone's status changes to appropriately update the record. But it's going to have to be done to some standards. And I think the logical place for those standards to be set is probably at the state level. Most of our responses take place out within a state. Now, that's outside of the fire service in some parts of the country where, as I mentioned, the wildfires earlier. We have a wildfire in the West. 5 states are there. They don't necessarily need the level, for example, that law enforcement does. It is very rare for law enforcement to actually put first responders from another state into service without another local in-state law enforcement partner with them, because the out-of-state people don't know what the laws are. They don't know what the use of force rules are that are permitted in that state, so they've almost always have a partner from a local law enforcement agency with them. Fire is probably the big exception, and they deal actually, because they've been doing it for decades, they deal with that very well today.
I guess what I'm concerned about is that I understand the whole policy issue of how a state works and the users knowing what information can go where and how it gets there. But the underlying network architecture needs to support some amount of security. Let's talk about encryption. Let's talk about data protection. Let's talk about lost device. What do you do? All of those standards for security needs to be consistent. If this is going to be a national public safety broadband network, you can't have every state and jurisdiction deciding, well, we're going to treat a lost device this way or that way. It has to be some type of standard which would drive the security of the overall network and how it operates.
And I agree that the standards are needed. As to how that works, again, I would turn back to what the law enforcement community nationally is doing today. They have that model on the wired side. It works very well. As the last mile provider, the broadband network is going to have to follow those unless the statutes are changed. And I would suggest that's a model that we would want to build on. And Global has reached out to the other responder services, and this has been a long invitation. This actually may be something that will drive that participation better than an invitation has so far.
Okay, thank you.
If I could add, though, too, Nina basically is also Nina's also addressing that issue on the NG911 networks, understanding that connectivity to the ESI networks is going to require some level of standardization and certification in order for that process to happen. Don't have answers yet, but they are looking at it.
I think that's going to be the last question.
Hi, I'm Rangam from Idaho National Laboratory. I have a question on IPv4 versus IPv6. We know this is a big problem which is kind of emerging from several different perspectives. Not just from the addressing space issue, but also from the security perspectives and other considerations. I'm sure each of these panel members have a view on, should we go to IPv6? Should even the public safety networks, the next generation networks, start with IPv6 rather than with IPv4? What are the pros and cons, and is there a suggestion or is there a thought on what we should do on this?
Who wants to take that?
Can I take that one?
Walt, yeah.
That's a great point. We've already talked to Aaron, and the fact that, basically for the most part this network doesn't exist right now, and it's evolving, and due to the fact that IPv4 address exhaust happened earlier in February, they were very adamant about the fact that we needed to seriously address IPv6. When we started doing that again in the NG911 space, we went to the vendors and said, are you going to have problems with this? They said, we really don't like V6 as much because we don't understand it, but the reality is all of our underlying operating systems and everything else support it. So if you tell us that it's a mandate, we think that it's very doable. We have also talked to Aaron about the feasibility of having, in essence, a large block of addresses assigned to deal with the emergency communication space, so that, in essence, you would be able to go within one single routed network, and, in essence, small entities would have IP address blocks that are larger than the existing internet address space. So it's personally, I think it's the way we have to go, and I'm not getting a whole lot of pushback on that, but it does need to be considered.
Anybody else? A quick.
Ditto.
Okay.
Yeah, and 6 makes some of the security things that we need to address so much easier.
Okay. I think that concludes our time slot here. Thank you all to all the panelists for your insightful comments. And beginning of a longer conversation, I'm sure, that we have to continue elsewhere.
So thank you very much, gentlemen. So we're going to take a 14-minute break till 2:30, and then we're going to rejoin for the last 2 sessions of the forum. And thank you. Erica Olson. Erica is a special counsel to the Public Safety and Homeland Security Bureau, and she's going to talk to you this afternoon about secondary uses of the public safety broadband spectrum. So with that, Erica.
Okay, we're going to take a little brief respite from some of the technical discussions, which I think have been really helpful so far, to have a little legal session here as well. So please don't stone me. I am a lawyer. Don't go running from the room. But I would hope that you take some of this in, and if it's not relevant to you, please take it back to your organizations to consider, because it's a very serious issue that has an impact on a lot of components of the public safety network. In particular, I wanted to talk to you today about an important open legal issue that could have a significant impact on the nationwide public safety broadband wireless network. And this is the issue of who, under the law, is allowed to use the network. Because this impacts the number of potential users of the system, as a result, it may also impact the cost of the network coverage, capacity, and other network considerations. Unlike public safety spectrum and other bands, the public safety spectrum in the 700 megahertz band is governed specifically by a statute addressing the services that may be provided. Specifically, Section 337 of the Communications Act dictates that this spectrum is for public safety services and goes on specifically to define what those services are in the statute itself. The Commission has sought comment on this issue before, and has previously concluded that the statute appeared to preclude the Commission from allowing non-public safety entities, such as utilities and critical infrastructure entities, to access the 700 megahertz public safety broadband spectrum. In the most recent fourth further notice, the Commission re-examines this issue in light of the expressed desire of many of the public safety community to include some secondary uses, which we've heard on a number of occasions today from the panelists, as a mechanism to coordinate emergency response, spread costs, and share infrastructure. The Commission's fourth further notice parses each of the elements of the sections out of 337 that we must consider in determining what the eligible uses of this spectrum are. I'll address each of them very briefly in turn, but I wanted to preface my remarks a little bit with kind of a plea, and that is, this is primarily a legal issue, and it requires careful legal analysis of the statute with factual support of legal assertions. While policy arguments are very important, even the most compelling policy considerations cannot trump the law. It's not enough always to simply state that Section 337 is met by a proposed use or a user. Clear, supported facts must present how the legal test is met. So, I urge you in commenting on these issues to keep this framework clearly in mind. So let's start with Section 337F and the definition of public safety services. Section 337F1A states that these services are the sole or primary purpose of which is to protect the safety of health or life. And let me read that just one more time. The sole or primary purpose of which is to protect the safety of health, life, or property. For those advocating secondary uses, the fourth further notice seeks to explore how this element of the definition can be satisfied. For example, are there ways to remain true to the letter and spirit of the statute, such as appropriate limits on use, if we allow access to the band for services that do not qualify as public safety services? And then again, those key phrases, sole or primary use. How does that come into play? Section 337F1B requires that public safety services be undertaken by a state or local governmental entity or by a non-governmental organization that is authorized by a governmental entity whose primary mission is the provision of such services, protection of safety, health, property. With respect to this element, the Commission sought comment on how to ensure that such authorizations are obtained and are legitimate. Section 337F1C requires that these services are not made commercially available to the public. If secondary use is permitted, the Commission sought comment on what types of financial arrangements might be used and how arrangements would comport with this section's requirements, not commercially available. And finally, the Commission sought comment on Section 337A, which is the division of spectrum between the public safety and commercial uses in this band. With respect to this section, the Commission sought particular comment on how any secondary use may impact the statutory division. Under that section, there are 24 megahertz designated for public safety services and 36 megahertz designated for commercial services. If you allow secondary services, the question is whether or not those services or those users erode the statutory division of the 24 and 36. For example, a comment was sought by the Commission on how usage limits, restriction on secondary uses to preemptible uses only, or how any other such mechanisms could be administered to continue to adhere to the terms of the statute. So that's a very brief overview. It's a very short statute, but a very important one that I urge you to pay very close attention to, or have your organizations or attorneys pay very close attention to. And with that, I'll close just by reiterating my initial plea, which is, I know many of you have commented on this in the past, but please consider refreshing the record for us and focusing your energy on the legal issues and the factual support for those legal assertions to help us navigate this statute. We can really only get to the policy arguments, such as those that were asserted today, for shared infrastructure, for common response missions, if we can first clear the legal hurdles that are in our path. So I thank you for your attention, and I will be around afterwards as well. With that, I'll turn the panel back over to Jennifer for our final element today.
Thank you, Erica. And for those of you who don't know me, I'm Jennifer Manor. I'm a Deputy Chief in the Public Safety and Homeland Security Bureau, and I have the honor right now to serve as Acting Director of our Emergency Response Interoperability Center. So for our concluding panel, which I know we're all that stands between you and probably drinks on a Friday afternoon, so we appreciate you staying with us. We're going to build on the discussion that was had earlier today on all of the great technology, all of the great possibilities, where public safety broadband is going, and really look at where are we going from here, the future. So how are we going to ensure that the network that's deployed actually takes advantage of the cost efficiencies that were talked about today? How do we ensure the network's spectrally efficient? How do we ensure that the network evolves, which is something critical to public safety and to our nation? So with that, I want to introduce our panelists, and then we'll go over their presentations. First, I'd like to introduce Bill Price. He's not in the room with us, but so he's participating via conference call today. And Bill's the Director of Broadband Programs in the Division of Telecommunications for the state of Florida. Secondly, and next to me is Dennis Roberson. Dennis is the Vice Provost for Corporate Relations and Strategic Initiatives and Computer Science Research Professor at the Illinois Institute of Technology, and he also serves as President and CEO of Roberson and Associates. Next to Dennis is Bill Schreier. Bill is the CTO at the Department of Information Technology for the City of Seattle. And finally, but certainly not least, or last but certainly not least, is Ed Thomas, who's a technology advisor at Wilshire and Grannis. So with that, Bill, if you can hear us, we'd love for you to turn the floor over to you. And I think we're just putting up the presentation now, which I don't know if you can see us at the same time that you talk. Bill?
Jennifer, can
Perfect.
you hear me?
Yeah, thank you.
Hello, Jennifer, can you hear me?
We can hear you. Can you hear us?
I hear you just fine, and I can see you as well.
Okay.
So if you'll bring up the first slide, let me know. I can't see the slides yet. So, okay, there we go. Great. Well, listen, I just wanted to thank you for the opportunity to participate in the process and share with you our perspectives on this important topic. Our perspectives that we're here to talk with you today about have been shaped by our division's purpose, our mission, and institutional experiences over 40 years, and I just wanted to give you a sense of what some of those are today. The institution and the people here have learned a lot of lessons from deploying and operating and managing statewide networks and services in partnership with vendors and suppliers to achieve economies of scale, meet diverse needs, ensure quality of service with minimal risk in technology procurement, and combining insourcing and outsourcing. The division was established in 1975. We manage today over 30 master contracts. The budget's about $300 million with 115 people. In terms of public safety, we're very involved with public safety planning, creating communications plans across a broad spectrum, and 700 megahertz interoperability channel plans, emergency communications planning, 911 planning, and law enforcement communications planning and networks. So if you go to the next slide. Again, just to give you a sense of the public safety challenge in Florida, by our estimation, there's well over 100,000 people in public safety. We've got a large geography to cover, a large incumbent population, and then we're unique in that we have a large number of annual visitors that are part of that challenge for public safety, large number of counties, large cities, and a large number of disparate proprietary radio systems, LMR radio systems, that are deployed in operation at different jurisdictions today. So we go to the next slide. So on this slide, I wanted to tell you a little bit about our statewide law enforcement radio system. Initially, back when they began, Florida was going to go about it by building and operating the network itself. But then they quickly realized that that was going to be much more expensive than going through a procure-as-a-service process, which they did. The estimate was that the state would save over $600 million by procuring it as a service rather than building, and operating itself. The state paid the contractor $40 million up front on contract execution, and we pay around $20 million a month to the contractor to operate the network today, which the funding is based on surcharges from vehicle registration and traffic violation fees. So it's a shared risk-reward type environment for the vendor as well. There have been a lot of challenges from building out and operating that network, a lot of lessons learned from both the procurement and the operation of that network. It's been operational statewide since 2004 as a single system. It serves 24 state agencies and 27 federal and local jurisdictions. The network has proven its survivability and performance in some pretty bad worst-case scenarios when we had 8 hurricanes in the 2004-2005 hurricane season. In our planning process, cost, coverage, and performance are critical issues across all the networks and procurements that we manage to balance against, the new technology that comes on the scene. In 2009, we provided the legislature with a report that stated that commercially available broadband services and equipment would eventually replace this network with converged voice, video, and data capabilities. And if we procure it as a service, it will be lower cost instead of building and operating a network ourselves. If you can go to the next slide. And we also, through a service procurement with the telecom industry, we operate a very large IP/MPLS backbone and access network for both state and local government. It's carrier grade. It's built on the telecom industry's service offerings. It's multi-vendor involved. It's a 5 nines network. The agencies and users can set up and create virtual networks and manage them through the management tools provided through the procurement. It supports quality of service, parameters for voice, video, and data. We achieve significant bandwidth cost savings over time and provides a great deal of interoperability that is allowing us to plan now for SIP and IMS-based services and applications. Today, this network supports many critical public safety applications for law enforcement. It also provides disparate LMR systems interoperability through IP gateways as well. So through these large data network procurements and operations, we've learned some lessons, I think, which apply to our thinking as we look at public safety mobile broadband. We found prior to this network, when we were using ATM, that even though you can be using a standard and you can use even a single vendor's equipment across multiple network operators, you can still run into interoperability problems. With the ATM network, we found that there were addressing issues across NNIs across multiple networks. I think it was brought up earlier that we all face a similar challenge in IP address space management, even before IP6. Just getting stakeholders to agree on how we were going to manage the IP4 address space was a challenge for us there. We can go to the next slide. So we've been thinking a lot about what's been going on with public safety mobile broadband, and where we arrive at basically is that the goals of the program, the goals of interoperability, cost containment, quality assurance, accountability, is more about governance than it is about the LTE standard itself. It's important to have the LTE standard, but we believe that governance should come first. I think one of your earlier speakers in the earlier panel was basically in the same posture as we are on that. We think that the foundations of the foundation for all this is what ultimately becomes the final federal program rules and terms and conditions for use of spectrum and funding that may become available. Our approach in Florida is to leverage existing governance structures and process, which in our case happens to be the Domestic Security Oversight Council that was formed in 2001, and that if our division is involved in a procurement for this, it would be a procurement as a service rather than build and own and operate ourselves. We would recommend that the federal government and we all work together to provide incentives that will leverage the state telecom divisions across the country, of which there's pretty much one in every state, along with the public safety organizations that we probably all are trying to serve, and organize ourselves and orchestrate and collaborate in that way. The next slide. So again, what we really need to know is what will be the federal rules and requirements for spectrum use and funding, and the effects on how we go about attempting to establish a single enterprise governance model in our state, which will ultimately result in procurement strategies. Will we have 50 procurements in the state of Florida? Will we have one enterprise procurement in the state of Florida? How will we operate and manage it? And then what we'll need to come out of that is what additional statutory requirements do we need to work on in our state? And that's the end of my presentation.
Thank you very much, Bill. So with that, I was going to turn the floor over to Dennis.
Thank you, Jennifer. We always have this pause as we await the arrival of the slides. I'll pause one moment here. The timing for this is extremely fortuitous for us in that we've just released a rather substantial study that some of you have commented on, that you've been reading just before you went to bed each night. You'll have actually quite a few nights of peaceful rest if you continue that process, so I strongly encourage it. But use that as a basis for my comments this afternoon. We do think that LTE is the basis of as we say in the slides, a responsible way forward. I think the last speaker and earlier speakers have talked about governance as a special and important issue. The testing and all of the others have to fit together, but there is a strong technical base to this, and with my very technical background, I'll keep on that theme. The key for this session is, once we establish a direction, how do we maintain it? How do we move forward to ensure that the future of public safety is, once instantiated, is a continuing situation of evolving to keep tack with the technology as it evolves and take full advantage of that marvelous technology that we use every day in our normal lives. 4 elements that I've pulled out that are critical to that are listed on the slide. First of all is taking full advantage of LTE, and in particular, the very robust priority access and preemption capabilities that are inherent in that technology. Second, and a bit more controversial, is as we move forward with the devices within the 700 megahertz band, that we are mindful of the band class, that the band class itself is in fact built into all the devices, so that there is the commercial volume for those devices, so that we are able to realize the goal that we've talked about, that we would get the economies of scale that exist. Even more controversial is the next one, wherein all of the infrastructure providers have the capability to deal with the band class 14, the band class for public safety. This will allow for the devices themselves to roam across all of the commercial bands, and I'll highlight this more in a couple slides. Finally, we do need the full regulatory structure and support to ensure across the board, and being the last panel is a great place to be. There are many aspects of this, be it security, the applications, the various elements above the underlying LTE that are so critical, that we have that support built into the regulatory structure and the requirements that are inherent in that. A highlight that probably is not required any longer given how late we are in the day for LTE, but LTE is really important. LTE, first we need to make sure we all recognize that this is a data network that we're talking about. So the device at the other end is this device. In fact, I was going to have Harlan stand up because I've seen him using one of these for a good bit of the time, but this is the end user device that we're talking about. It's not the device that we would more normally think about, some embodiment of one of these, because it's data network. The critical part is that we have a data network, a packet network, where many things are different from what we're traditionally familiar with in the public safety environment. A lot of this has been raised from the perspective of the D block, the famous D block that gets so much press, but really the action is far larger than that. It is the entire 700 megahertz spectral band and all of the different commercial and public safety elements within that band that can be enabled by proper sharing and proper use of the technology. The driver for all of this is not, in fact, and has to be ensured to be, not the commercial requirements only. We need to build on top of those, but the key requirements that have to be met are those that have been developed over an extended period of time by public safety. And I've highlighted some of those here, but it is really crucial that we do take advantage of those requirements, but meet them in the context of the new world, and I've highlighted some of those. We often talked about ruthless preemption as being critical. Well, in the new world of packet data, ruthless preemption has no meaning. It really is packets. So the packets are prioritized, and we get that prioritization as the key. This is more the slide that I was really addressing a moment ago, the requirements that have been built up over time from public safety, and ensuring that all of those are in hand, the automatic nature of the ability to use commercial networks, the seamlessness, the insurance that public safety always gets access to a commercial network, always has channels assigned to it, and always gains priority within that environment. Those three elements are highlighted here, but those are the critical parts that you cover all of those, and they are robustly covered within not only the LTE specification, but also within the embodiments that have been produced out there. This is more in depth, and I'm watching this very ugly box over here that has a red blinking light that says my time is expiring. So obviously the time is not appropriately being controlled. But the public safety requirements, okay. So the public safety requirements are listed here and how they're embodied within the LTE environment. Key is that we move forward as we are looking to move forward, that we move forward in a way that meets public safety's needs, but takes full advantage of the commercial evolution that is taking place, not only in the release 8 of LTE, as has been highlighted before, but release 9, 10, 11 as it moves down. And the optimal way to do that is to use that as the guiding light, but use it in the context of the requirements, the critical requirements, that must be met requirements that public safety has. So with that, I will conclude and stop that nasty blinking red light and pass things on to Bill Schreier, and take it away, Bill.
The trick is to ignore the clock.
Did I write that down?
So Jennifer, thank you. Thank the Public Safety Bureau. Thank the Commission for allowing us to come in and talk about this important subject today. And as usual, the Chief Technology Officer will be challenged by the technology until the slides come up.
At that time, that's why the clock is not right.
There we go. So where do we go from here? Killer apps, innovation, architecture, broad-based use. These are my comments today. So this is a map of the waiver jurisdictions. It's a map I actually stole from the FCC. David Firth actually originally created this. I innovate, I take the appropriate technology here. And then here, the red circles highlight those jurisdictions that have received BTOP grant funding to actually build out their networks. And I'm a little bit challenged here because New Mexico received funding, but I've circled Arizona. So I don't know the difference between New Mexico and Arizona. I apologize. It illustrates the need for local control of these networks, I think. Although actually Arizona, both Arizona and another jurisdiction have money to build out, even though they don't have BTOP grant funds. The nationwide network. So here I'm going to channel Bill Clinton. It's the apps, stupid. Sorry, not stupid, but it's the apps. This is about applications. We love to talk about the technology. We love to talk about the technology that goes into the network or into the devices. But if you're a first responder or a second responder on the ground, it's about the applications. For example, we had an incident here about 1.5 years ago where a police officer was killed. It was a very anonymous killing on Halloween of 2009. The only reason that police officer was caught is because the front video dashboard cams of police cars in all of Seattle were examined for video, and they found a very unique car that was the perpetrator's car. But if we'd been able to beam that video back in real time, we'd been able to store it at a 911 center or another location, and we would not have had to examine all the computers and all the police cars. Augmented reality is another app. So I'd like to be able to hold up a tablet device or something like this, and little tags appear above all your heads on this device, and I'd be able to tell who you exactly are. It sounds like it's a pretty frivolous application, but if you're a police officer in the field and you're actually able to do that and identify who's dangerous in a crowd, it could be important. If you're an EMT and you're holding it up and you could see the medical history of the people that you're walking in to see, you better be able to treat them. Things like augmented reality and next generation 911. And there are other applications we can't envision. The one that's shown up here is actually a crime map that's available on seattle.gov. It's a mashup of crimes that police officers clearly need to be able to do their jobs. There's been a continuing explosion of consumer use, and we will see the same sort of explosion in public safety use or public sector use when we build these networks. But this requires both dedicated bandwidth and the ability to innovate, or innovation. How do we leverage commercial efficiencies in this? Well, first of all, I would say that we need an architecture. Commercial networks start by building a nationwide architecture and fitting local networks into that nationwide architecture. I'd submit that public safety needs to do the same. Nationwide architecture, public safety requirements, and then rules for enforcing that, and then you build the local networks. I'd suggest that this rulemaking needs a minimum of such rules. Certainly, a minimum set of rules allow innovation because you can build innovation upon those standards. But too many rules stifle that innovation. So here I'm channeling Barack Obama in his State of the Union address where he talked about we need to innovate the economy. We need to innovate with this network. In terms of public safety and public sector requirements, we in the public sector need to minimize the number of requirements we put on these devices and the networks. If we put too many requirements, too many that are unique from the commercial sector, all of a sudden the cost of the devices and the cost of the network will go up. The further we stray from the commercial devices that are available, the more expensive this network will become. I'd also suggest that we local governments need to have standard interfaces. I mentioned XML, extensible markup language here is one. So that our local applications, our computer-aided dispatch systems or records management systems interface to the networks in a standard fashion. And we should also have some backwards compatibility, for example, to 3G to increase coverage and capacity. We need to allocate enough spectrum. Dennis referred to this, but we need to allocate enough spectrum today. One of the problems with LMR networks, with the voice networks, is that we've had balkanized spectrum in many different pieces. We need a good-sized chunk of spectrum for public safety. I'd submit that we need open source development. Just like your iPhone or your BlackBerry or your Android phone has hundreds of thousands of applications. We need a national public sector app store. We need public sector application competitions. And here I'm channeling Vivek Kundra, the CIO of the United States, and Anish Chopra, the CTO of the United States. Vivek pioneered the Apps for Democracy. Maybe we need an Apps for FEMA, an Apps for Emergency Management, or an Apps for the FCC competition to actually spur application creation for public sector. We've got a lot of cops and firefighters out there who have a little bit of time who could develop such apps as well as professional apps builders. And we need cross-discipline apps. The one I use as an example here is a building department of police and fire. The president in the State of the Union address talked about building plans over this network for firefighters that would show where hazardous materials are. Well, I'd submit to you that police officers go into buildings, building inspectors go into buildings, and each one of those, using a common app, can build a database that's useful to all, if the network's available to all. And in terms of bandwidth sensitivity, I'd suggest certain sorts of things like adjustable frame speed video. Maybe the video from a police car would be at 6 frames per second during normal times, but you could quickly ramp it up to 30 frames per second for higher quality during an incident. And finally, continual evolution. The users, I think, should be the entire public sector, not just public safety. And Erica did a good presentation on the issues and the challenges with that. Again, we need a nationwide architecture, nationwide engineering, but a local implementation, an implementation in our cities and our states where the first responders are at. We should minimize the number of LTE cores or central switches that we have. Most commercial networks have something less than 10. We probably need less than 10 in the public safety network as well. We should use clearinghouses, as the gentleman from Cineverse talked about earlier, and we should have a regular dialogue with carriers and try to implement the innovations that they bring to the network as well. So in summary, a nationwide architecture and public safety requirements first rather than a plethora of rules, a minimum of rules necessary to gain interoperability. This is about public sector, not just public safety. And we need a new model for deployment, something that is shared services between agencies and disciplines as opposed to a whole series of local networks we stitch together. Leading edge, not bleeding edge. I loved John Powell's comment that in public safety, bleeding edge actually involves real blood. And again, let the commercial networks lead in this. And finally, let's use information technology techniques. open source development, open source software, and application stores to make this happen.
Thank you, Jennifer, and thank you for inviting me. As some of you know, I used to be chief engineer here, and I bring this up for a simple reason. When I took that position about 8 years ago, my predecessor was Dale Hatfield, and he sat down with me and we talked about the major open issues. One of the major issues was public safety and inner working of networks. That was about 14 years ago. When I left, and Julie and I, who Julie was my deputy at the time, we had the same conversation, and the same subject was one of the high priorities. We're now 6 years later, and we're in the same place. So what I thought I would do today, and excuse me if this sounds a little arrogant, but I think somebody had to do it. What I wanted to do is basically present to you what I consider the essential ingredients so this ongoing dialogue stops and we build ourselves a broadband inner working network for public safety. And I have 10 suggestions. Now, admittedly, the devil's always in the detail, and with the short time available, I'm going to just give you the headlines. So, let me try it. The first one, obviously, any plan that we come up with has to be independent of what comes out with the D block, whether it's included or is auctioned. So it's got to go both ways, because God knows how long that's going to take to settle. Secondly, it should be fully funded. And when I say fully funded, I mean both on the capital side for construction and ongoing operating expenses, and which obviously was going to take some work on the congressional side. I also think that any plan should support both federal and local public safety officials. And here's one that I'm sure is going to be extremely controversial. I think the license holder should be strictly administrative, have absolutely no commercial interest, and basically have no say how the license is going to be used. The license, how it's going to be used, how it's going to be segmented, should be at the direction of the NTIA and the FCC. And all it is a lockbox. To obfuscate it with commercial interests makes this extremely difficult to go forward. On the other hand, in the future, if the FCC and the NTIA think it makes sense in concert with public safety to do some commercial sharing, terrific. We need a spec, and when I say a spec, I mean one in consultation with public safety, but at the discretion of the NTIA and the FCC, which is basically the substance of an RFP that goes out. And I think there has to be an RFP that goes out. We could debate who should administer that RFP, whether it's DHS, whether it's the NTIA, whether it's the FCC, or some combination thereof. But the point is, I think an RFP should go out. It should allow for state, regional, or national networks, and obviously everyone, if you choose different vendors for state networks, obviously they have to be certified as inner working. So that brings with it a requirement that, again, the NTIA and the FCC put together a test spec to certify the interoperability, that the networks basically meet the standard. Once a vendor is selected, that vendor obviously must certify that he or she will build a network that's consistent with the specification and interoperable. Once it's built in pieces, it has to be certified, and that's certified against the test spec. Finally, since time is very short, let me stop with this note. There's always the issue of evolution and of monitoring this. I believe there should be a sitting panel charted by both the NTIA and the FCC of public safety experts that does several things. Number one, it monitors the construction of the network. Number two, it monitors the effectiveness of the network as it is put into operation. And number three, and finally, what it does is basically make recommendations for improvements on both applications and also efficiencies of the network. Now, that's a hard bullet to swallow, but all I'm talking about is what a company would do when it has a big project it wants to outsource. Builds a specification, puts out an RFP, and then it monitors, and obviously it's got to pay for it. If all those ingredients don't come together at the same time and place, we're going to have this conversation maybe 4 or 5 administrations of FCC commissioners in the future. So let me stop there.
And thank you, Ed, and thank you to our panelists. Really great presentations. I wanted to start actually with a question for our friend who's in Florida on the beach, I have a feeling, Bill Price. Bill, I wanted to return to one thing you said at the beginning of your presentation, was that based on your experience in Florida, that you wouldn't actually build a network, that you would actually purchase this off the services. Can you just build on that a little bit more? Because I thought that was very interesting.
Sure. I mean, the division over time in the past has tried to build and operate its own networks and found that that's just way too expensive. And we found over time, through many procurements and generations of people that have worked here, that we achieve all the objectives that the state puts on us, minimizing cost and support for features and functionality and quality of service and accountability, by procuring telecommunications as services from the industry. And typically there are multiple players involved. You'll have a prime with multiple subs. In Florida, like on our MPLS backbone network, it's a combination of AT&T, Verizon, and CenturyLink, who are the dominant CLECs in Florida. They then subcontract to folks like Windstream and Fairpoint and others in smaller footprints. That's what we've found to achieve the greatest economies of scale, and it gives us a much greater flexibility at a lower risk and a lower investment cost to migrate to newer technologies as they become available.
Okay, well, thank you very much. Dennis, I wanted to build on one area because of that evil clock over there that I don't think you got to touch on it quite as much, which was in one of your early slides, you had a statement about having the infrastructure see all the frequency bands in the 700 megahertz or the band classes. So I was wondering if you could build on that a little bit.
Sure. Well, one of the exciting elements of LTE is, in fact, that you have the common technology across, and it at the surface sounds really, really powerful. The nasty little secret underneath is that the 700 megahertz band is divided up into band classes. And if you drill down even further into the technology, there are chipsets that people develop that match those band classes. So in fact, the worrisome feature of the public safety portion of the 700 megahertz band is that it is its own separate band class. In fact, the D block plus public safety is a band class. The likelihood, if the tenets on my early chart were not met, is that you would lose a great deal of the value by virtue of the fact that chipsets would not be developed for the public safety band class, because it's much smaller than the commercial band classes for Verizon or AT&T or others who might be there. And you would therefore not be able to use that value. The other parallel one is that once you have the public safety radios in that band class, you'd like to have the infrastructure that would allow for roaming across, and that would include not only the large holders, but also the regional holders. As we had in an earlier panel, there's such great concern for the needs of those in rural locations where disasters do strike and have national impact. But by allowing for complete roaming of the device, the public safety band class across all of the infrastructure, it would allow for those devices to be used anywhere, even for a rural carrier. So the combination of those two provides the real fulfillment of the dream of having LTE and having this common technology that is harmonizing a lot of the capabilities between the large commercial needs and the needs of public safety.
Thank you. Thank you. So, Bill, I want you to try and channel maybe a great architect for a minute. And I was trying to think of great architects, and I was going to say Frank Lloyd Wright, but then I thought maybe I was going to go with Vince Cerf. And so what I wanted to understand from you, I think you said the first step in your presentation always went back to architecture. And so who would be the architect of the architecture would be my question to you, especially with such a diverse, public safety is a diverse and complex group of agencies, and you're making it even more diverse and complex by making it the public sector as opposed to just the public safety community.
So that's a great question as to who the architect is, especially given the fact that many of the speakers today have talked about governance being the first and foremost issue. And I would agree that governance needs to come first. So I don't know that I can suggest a structure for that, but I know who needs to be involved. The FCC needs to be involved from a regulatory point of view. The NTIA needs to be involved both from the PSCR, the Public Safety Communications Research Group, and from the funding point of view. The early builders, those that have waivers and are actually building these networks today, need to be involved. And also, certain organizations like APCO specifically and NIPSTIC have expertise for that architecture. And I might suggest that our grant programs today that are administered by DOJ and Department of Homeland Security and Department of Commerce might be channeled to actually create that architecture. Could I also make a comment on Dennis's statement about devices and 700 megahertz? I think what you said, Dennis, was that the public safety chipset should be in every device that's manufactured. That scares me. That scares me from a cybersecurity point of view. If every device, every commercial device can broadcast to the public safety spectrum.
Okay, thank you. And if you have a response, or Ed, did you want to?
Yeah, about how you build the architecture. First of all, absolutely no argument, Bill. You named the right people, and maybe there are more after we have a chance to think about it. But somebody has to be in charge. And as far as I'm concerned, I really believe it's got to be the NTIA and the FCC that basically takes all the inputs, and then very much like a general. They take all the inputs from the junior officer, and then the general says, here's the strategy and this is the direction we're going. In this case, this is the architecture. And if necessary to get consultants or the right technical expertise to do it, you clearly don't do it independently of public safety, but having been involved in this, and I'm sure you're seeing it now, you put a lot of smart people in a room, you're not going to get any consistent architecture unless somebody sits there and takes all the inputs and says, this is the way we're going to go. So I think it's got to be eventually, I've heard it all, and this is what we're going to do.
I had one question for Ed before I open up the questions for the floor. You had talked about an RFP process, and I thought what was interesting, not that I didn't think your whole presentation was interesting, but what I thought was particularly interesting was I thought you talked about the RFP being on a national, regional, for national, regional, and local networks. And I wasn't sure how that would ultimately, what you were envisioning would ultimately be built, or was it what was most cost effective, or how that would work. So I was hoping you could elaborate a little on that, please.
And first of all, it goes to architecture and then it goes to details. Obviously, if this thing is going to be built at a local level, a state level, a regional level, or national level, it's got to have an architecture and fit together. First and prime. Okay, now the question is how many contractors you're going to have. If I put out an RFP that is specifically is specific enough and technically valid against an architecture, even though it's more difficult the more contractors you have, you could conceivably have the contractors done at a state level, a regional level, or a national level, but it all fits together. So that's all I meant. And why I brought it up that way is one of the things whoever administers the RFP could decide, if I sum up all the costs associated with a state by state a bunch of contractors, is that more expensive or cheaper than if I give it to one contractor at a national level and I make the choices that way? Obviously, if it's more fragmented, control supervision becomes more difficult, and that's a trade-off that has to be considered. But at the end, you have to have a consistent national network, whether it's built in pieces or built by one contractor.
I wanted to open the floor up, open the microphone for any questions from the floor.
John Powell from NIPSTIC, and Ed, I'm going to be blunt coming back to you on your proposal. We can look across the federal government to programs like you're talking about where they've been driven from the top down, including several recent ones at DOD, or excuse me, at DHS, where millions of dollars of taxpayer money was wasted because the end users at local and state government said, you didn't involve us, the architecture does not work, and we aren't going to participate, thank you. If it is designed at the federal level, you will not have state and local participation. They have to be involved, they have to have control over the network to the degree that they believe they need it, or they will not participate. There's no way that you can force them to participate.
First of all, thank you for being very direct. And let me be direct right back. Okay, first of all, please don't interpret anything I said as saying no involvement at the local level. I think you absolutely need involvement, but you also need a decision maker. We've been talking about local involvement and local control for 50 years, and we still don't have an interworking network. My point is you get all the involvement in, but you have to someone to do a decision maker. And I'll make you a bet of the bottle of wine of your choice. It could be very expensive. If I give you a network that comes to very close to what you want and it's free to you, you're going to use it. And that's what I'm really saying. So all I'm saying is the only real difference here is you need a decision maker. And you can't do it in every local area, be able to give its own requirements, its own applications, and oh, by the way, it may or may not fit together. So.
Just a quick response. We think that the Commission gave us that decision maker already when they issued the national license. And with the requirements that were in there, that is under our control. It's the appropriate organizations that represent public safety.
Can I do one?
You can.
I gotta have the last word. I'm sorry for those of you who know what. I mean, honestly, you do have that organization, but there's at least one notable failure, okay? And we're still having the conversation right now, and we're not moving forward. So it could work, but it's got to have a different flavor. And it has to have much more supervision from the FCC, in my judgment. I'm not so concerned about the entity. I'm concerned about pulling in one direction and at least having some pretty heavy-duty federal regulatory supervision to make sure it goes in the direction that basically that the government wants, and the government includes the local governments. And excuse me for grabbing the last word.
Jennifer, this is Bill.
Questions from the floor?
Jennifer?
Yes, go ahead, Bill.
This is Bill Price. I'd like to comment from a state perspective. I think there are a lot of resources, both in network assets, funding, and expertise at the states. And I think that whatever we do going forward, we need to attempt to reach out to the National Association of State Telecom Directors and their organizations to attempt to get them to be as involved as possible.
Yes, Bill.
So, Ed, I think your comments, your points were great, and things like fully funding and having a decision maker, but fully funding doesn't mean fully federal funding. I think state and local governments have to have a say in this as well, but they have to put their money where their mouth is. Cities and states need to bring funding to this as well as the infrastructure that Bill Price mentioned. If we want some measure of local control fits into a national architecture, we also have to bring dollars to the table as well.
Absolutely no argument with me. And if anybody puts skin in the game, they should have something to do with the supervision of it. Absolutely.
Thank you.
So, any questions from the floor? Then I'm going to thank our panelists, both for this panel, thank our panelists from earlier panels and our speakers, and also, of course, thank our audience for participating. We think it was a very good day, and we very much appreciate everyone's attendance and participation. Thank you.